Welcome. We're coming to you from World Engineering Day 24 hours live. We're following the sun across all the global time zones on this World Engineering Day for Sustainable Development, from New Zealand to Costa Rica and everything in between. We will be live streaming all the amazing activities and events to celebrate the important work engineers are doing around the globe. Coming to you directly from Epicenter Studios. Follow along for free on the World Engineering Day homepage. Now, for the next 3 hours, we will hear from engineers and institutions across Ghana, other parts of Africa, and a special live cross to France. With your host, Kartik Mohandas.
Engineering enables the development of societies and economies throughout human history and acts as an inexhaustible driving force for the progress of civilization. Engineering wonders are significant symbols of human history. The Industrial Revolution transformed our world from an agricultural economy into an industrial one. Every major breakthrough in engineering has significantly elevated productivity and profoundly improved human lives. Engineering facilitates fast travel and communication between hither to distant places. Therefore, we are all part of the global village. The World Federation of Engineering Organizations, or WFEO, was established in 1968 under the support and initiative of UNESCO. It brings together more than 30 million engineers from over 100 nations. For 50 years, WFEO has relentlessly promoted international engineering cooperation, a key force for the progress of the modern world. Nowadays, engineering innovations are developing rapidly. However, we're still facing global challenges such as energy shortage, environmental pollution, natural disaster, climate change, hunger and poverty, resources exhausting and diminishing of biodiversity. It is the mission responsibility of engineers around the world to address those challenges. Technological innovations are driving new industrial revolution. The progress and innovation of engineering will become an important means of progressing society and modern life. There will be a series of major innovations in such fields as energy, environment, materials, biology, agriculture, information and communication, manufacturing, construction, space utilization, and marine resources, transportation, social services. It lies in the hands of engineers to develop appropriate technologies and resources to promote the quality of the human lives and achieve a shared sustainable future. The World Federation of Engineering Organizations will continue its leadership and influence in the field of international engineering and make unrelenting efforts to build a better sustainable world for us all.
Engineering shaping sustainable future, a shared future of humankind.
Ladies and gentlemen, friends from across the globe, welcome back to World Engineering Day. And we are here at the studio 24 hours live, and we're going to be moving from one part of the globe to another as we cover 24 hours right from Japan, China, India, Singapore, right up to Costa Rica. That's right. We've just finished with our global hackathon that covered the two regions of India and Singapore. And very shortly, we'll be moving our focus to Ghana, another very interesting and upcoming region. And of course, during that period, we are extremely proud to showcase the 9 finalists in the World Engineering Day Global Hackathon. There were over 400 entries in the first hackathon, and there have been some very challenging, interesting, and very specialized entries that have come through this year as well. And of course, let me remind all of you out there, tell your friends, whoever's interested in engineering, science, or is just an avid watcher of anything scientific, to come on board and watch us on worldengineeringday.net. And of course, if you want to be interviewed or have a little piece of your mind on our social media ladder, then hashtag World Engineering Day. And of course, now it's time to go across to Ghana, the country of focus. And I'm joined now by Kwame Nkrumah from the University of Science and Technology in Ghana. So welcome everybody, and over to you, Kwame.
From these humble beginnings, and despite difficult economic times over the ages, partially caused by more military interventions, resultant student agitations, strikes, etc., the Kwame Nkrumah University of Science and Technology has grown into a very dynamic institution, producing an equally dynamic and highly skilled workforce, dominating practically every industry in Ghana. There is no industry of significance in Ghana without a KNUST product. From civil engineering to banking, from architecture to agriculture, from pharmacy to the film industry, from hydroelectric generation to animated cartoons and the visual arts in general, and many other arenas, you'll see the dominance, or at least a vital presence, of KNUST alumni.
As one of the universities set up in our pre-independence era, the KNUST has and continues to be a trailblazer in the training of high-quality manpower in agriculture and natural resources, architecture and planning, engineering, science, health sciences, art and social sciences, unparalleled on the African continent, in tandem with our vision of advancing knowledge in science and technology for sustainable development in Africa. We thus pride ourselves as the nation's premier science and technology university, and obviously one of the best on the African continent. Our slogan of Nyansapo Wusaneno Pajimba, which translates as the knot of wisdom is untied only by the wise, amplifies our mission to provide conducive environment for teaching, research, and entrepreneurship training in science and technology for the industrial and socio-economic development of Ghana and Africa. Our research output has resulted in the development of several equipment and products, which have brought relief and efficiency to many. In addition, our research and development efforts have helped us set up several small and medium-scale enterprises, and have also helped shape policy and methods in bettering the fortunes of many in Ghana and Africa. Our international reputation has and continues to serve as a reference point in matters on science and technology, research and education. We believe that the future belongs to those with sound science and technology acumen, and the KNUST is poised to provide the needed platform and leadership in this direction to change our society for the better. Join us as a stakeholder in the next level of our development, and together let us help build our country to a level we can all be proud of.
Good morning, good afternoon, good evening, wherever you may be on the face of the earth, as we celebrate World Engineering Day 2022. I am Professor Samuel Kofi Ampadu, a past provost of the College of Engineering of the Kwame Nkrumah University of Science and Technology in Kumasi, Ghana, and a past president of the Ghana Institution of Engineering. I'm here this afternoon because I chair the committee that put together Ghana's component of the World Engineering Day 2022 24-hour live. Please enjoy our videos, and I hope they will give you a good understanding of engineering in Ghana, which is typical of most countries in Africa. Thank you.
Build Back Wiser, Engineering the Future. From the heart of West Africa, specifically Ghana, I am Samuel Wanda, reaching you live from the Kwame Nkrumah University of Science and Technology, KNUST Kumasi, under the Chancellorship of His Royal Majesty, Nana Otumfuo Osei Tutu II, and the Vice Chancellor, Professor Mrs. Rita Akosua-Dixon, Yamamo Akwaba. As a top university in Africa and the best ranked in the West African sub-region according to the US News and World Report 2021, our contributions to engineering education and technology transfer has been very enormous and very profound. So as we celebrate engineers today, we have categorized our segments into three major parts. The first of which will describe for you a bit of engineering education and technology transfer through the corridors of the College of Engineering KNUST Kumasi. Now, let us hear from the Provost of the College of Engineering KNUST Kumasi. Welcome to the World Engineering Day.
I would like to welcome you to the World Engineering Day on behalf of the Vice Chancellor of the Kwame Nkrumah University of Science and Technology, Professor Rita Akosua-Dixon. I am a professor of civil engineering. I am the provost of the College of Engineering, Kwame Nkrumah University of Science and Technology, and I am a fellow of the Ghana Institution of Engineering. The Kwame Nkrumah University of Science and Technology, KNUST, was established in 1951 and admitted the first batch of students in 1952. The then School of Engineering was one of the two institutions that were established right from the start. The School of Engineering had three undergraduate programs: BSc Civil Engineering, BSc Mechanical Engineering, and BSc Electrical Engineering. From a very humble beginning of less than 100 students, the College of Engineering has grown to a student population of 12,000. We have grown from running 3 undergraduate programs to running 18 undergraduate programs and another 40 postgraduate programs. The College of Engineering, as it is known now, has made a lot of contribution to engineering practice in Ghana. Firstly, in terms of the educational arena, College of Engineering helped establish 2 universities. These are the University of Mines and Technology at Takwa and the University of Energy and Natural Resources in Sunyani. In addition, the college has also helped mentor a lot of other affiliate institutions. Amongst them, we have the All Nations University, we have the Central University, we have the CAF University College. We have also done a lot of work so far as the engineering profession in Ghana is concerned. Most of the engineering installations in the country are manned by graduates of this college. To mention but a few are the Volta River Authority, VRA, ECG, GRICO, Ghana Water Company, Ghana Highway Authority, Feeder Roads, Department of Urban Roads, and the rest. The College of Engineering has also, in terms of personnel, has also helped train over 90% of all engineers who practice in Ghana. The chief executives of most of these companies, including GNPC, Ghana Gas, and the rest are all products of this university. In addition to all this, we have also been able to contribute enormously to the development of the engineering practice. Most of the presidents of the Ghana Institute of Engineering are former students of the College of Engineering. Now, with regards to teaching and learning, we have been able to introduce a lot of technology into the way we do our teaching. We have brought in audiovisuals. We have also brought in other visual aids that helps us in the teaching and learning within the college.
As a biomedical engineering major, I got the chance to pick the finest Ghanaian minds, lecturers and students alike. Having engaged the process, I am confident that in a few years to come, I'll be able to pick up the most daunting issues in the healthcare system and solve them.
Growing up as a child, I was always fascinated by the concept of flight and the idea of using sciences to solve our daily problems. So it wasn't much of a brainer when I was supposed to choose a higher education path, which was engineering. So I did a bit of research and I found out that not only is KNUST the best engineering university in Ghana, but it is also responsible for producing majority of the country's engineers. So I decided that KNUST was the school for me. This makes me feel ecstatic and gives me a sense of pride, knowing that with the right tools and with the knowledge impacted in me by my lecturers, I can contribute effectively to the solution generation process of my country.
The laboratories have been upgraded and we have brought in a lot of equipment. We have a first-class petroleum engineering laboratory, which is worth about $12 million US. We have also been able to procure other equipment to the tune of about 7 million euros, which covers the areas of civil engineering, electrical engineering, mechanical engineering, materials engineering, automobile engineering, aerospace engineering, and the rest.
Engineering Day, to me, is a day where engineers and we as people in the various fields of engineering come together to show society and the world at large the positive impact the concept of engineering has had, especially in the modernization of our world. I believe it's a day we educate people on the career opportunities in engineering, inquire from them what more we can do, and last but not least, a day we celebrate engineers.
In addition to the laboratory training, we have also been able to add other components. And one of them is the introduction of a Student Innovation Center. The Student Innovation Center is more like an extracurricular club, which has a membership of 1,750 students. These students undergo a lot of activities. Some of these activities include training in robotics, training in Internet of Things, training in Arduino, and training in artificial intelligence. The mandate of universities is to train students, undertake research, and do what we call service to the community. The aspect of the service to the community involves getting a developmental agenda for industry. In order to do that, the Technology Consultancy Center, TCC, was established in 1972 by the government of Ghana and was placed under the watch of the Kwame Nkrumah University of Science and Technology. TCC has since 1972 played a major role in the development of industry, both in Ghana and in the West Africa sub-region. TCC has done works in La Côte d'Ivoire, it has done works in Togo, Benin, and Burkina Faso. TCC plays a unique role in both academia and industry. Therefore, TCC has been placed both on the KNUST campus and on an outstation at Swami called the ITTU Swami. On the campus, TCC has laboratories that they use in undertaking various engineering processes. Once they finish with their laboratory work, they need to do technology transfer, and that takes them to SWAMI. Both on campus and at the SWAMI ITTU, TCC employs the services of students. First and foremost, they train the students for the students to understand how to use the equipment. Having trained the students, they team up with the students in coming up with appropriate technology implements. In addition, they also provide service to the industry in terms of the artisans who are at the SWAMI enclave. Some of the activities they undertake include drilling of various metal parts, molding of various metal parts, and the rest.
As part of the college's vision to produce students that are well equipped for the industry, they have instituted a number of measures, amongst which includes the introduction of engineering in society and the introduction of a compulsory third-year industrial attachment and the establishment of the Innovation Center. This has equipped me with the needed skills to impact the world of engineering and to appreciate the fact that engineering goes beyond the books.
I seek to make engineering more practical and relatable by showing what it entails to the general public. I seek to achieve this through clubs and the use of science kits like the Arduino kits.
With the upgrade of TCC into a UNESCO Category 2 Center of Excellence, TCC is now specialized in innovation, manufacturing, and technology transfer. It is going to use this opportunity to upgrade the skills of students and also help upgrade the skills of the local artisans at the SWAMI enclave. So this has been the Kwame Nkrumah University of Science and Technology's College of Engineering's contribution to the engineering profession in Ghana. We have been able to contribute to engineering education. We have been able to mentor institutions. We have been able to mentor other affiliate institutions. We have also been able to help with the nurturing of the TCC into a world-class center of excellence. Thank you for being part of the World Engineering Day. Thank you for having me, and hope to see you during next year's celebration.
Biomedical engineers in training, we will solve the healthcare issues in Ghana through innovation and technology. But let's start with one patient at a time. Engineers,
We imagine, we innovate, we invent, we make things happen. Engineers, Mayadi.
Let us not neglect the safety of others and the preservation of the environment. Engineers, Akpe.
I'd like to say a big thank you to all the brilliant engineers out there who are coming up with innovative solutions to our everyday problems. Happy World Engineering Day to everyone.
As engineers, let's keep being problem solvers and keep contributing our quota to sustainable development. Engineers, Wondanyeshin.
I feel excited to be an engineer, and I want to encourage all my colleague engineers all in Ghana and all over the world that we are in a very good profession. We may not have had our space, but this is the time to take our space. And we believe that we, together with a good regulation, good practice, ethical practice, professionalism, we can take our continent far and we can take our countries far.
And today we share our joy, our adversities, and most importantly, our success story with all gathered here. First, I would like to quote a favorite verse of mine in the scriptures, Psalm 68 verse 19, which says, "Blessed be the Lord who daily loads us with benefits, even the God of our salvation." Therefore, our foremost gratitude must go to God Almighty for his countless blessings on our lives and seeing us through thick and thin to this memorable day. Our heartfelt gratitude also goes to our dear lecturers for imparting in us knowledge and good morals, even though we gave some of you hectic times. From hindsight, we say we are duly sorry. To my fellow graduates, the road was muddy and rough, but we still managed to get here. We also deserve a round of applause.
Welcome back, ladies and gentlemen. This is World Engineering Day, 4th of March, and we are here back in the studio, 24 hours live, going from one end of the world to another. So all of you out there joining us, please, you can watch us live at worldengineeringday.net. But of course, as we move through our global hackathon, it's also important to check out what you guys are saying. So that's why next up, after Kwame Nkrumah, we've got to see what's happening on our social media posts. And for that, I'm now going to be joined by Melanie, who's our project manager out here in the studios, who will tell us what's been happening on the social media boards. She's here to join us now. And as I talk to Melanie, do hashtag World Engineering Day.
Hello.
Hi, welcome, Melanie.
Welcome. Thank you for having me. I'm looking forward to sharing what's going on in social media. So, first up, if we share my screen here, and you can see behind me as well on on our green screen behind us what's going on. But there is a lot happening that we've got a lot to catch up on. So, first up, here we go. iGEM headquarters. This Friday is World Engineering Day, yes, and they've got people out there, and it looks like they're doing something all about sanitation and clean water. That looks like a great event that's going on. So go and check out that bit.ly link if you're keen to find out more. Stemulator, I love that name. I know, they've got so much fun stuff that you can do with the word STEM, science, technology, engineering and maths. But Stemulator here, engineers are the ones who bring the technology to make our lives simpler and bring comfort and to bring ease. They really, really do. So thank you for recognising engineers, Stemulator. We've got an Instagram session here. Looks like an event that's going on. That is magnificent. There.
That does look interesting.
Yeah,
that's right.
Containerized sewage. Yes. Okay. Excellent. Thank you for posting that. It's very. I mean, you know, poo's got to go somewhere as well, and engineers are the people to send it in the right spot. That's for sure. All right. So now a lovely Instagram post. This looks like a space thing. Yeah, World Engineering Day, we're celebrating 4 engineering heroes who have made a positive impact on health, people and the planet. Oh, these are engineering heroes.
That's right, and it looks
These
like the team
cool.
of Armageddon 2, I think, from
I'm
the looks of it. They're looking very dashing. And that looks like Meryl Streep on the right.
This might be the RA Engineers, Royal Academy of Engineers. They've got an engineering heroes. Yes, Tim Peake. Yes, I think this is from the Royal Academy. Awesome. Thank you. Well, we're hoping to show some of these videos that were launched today, so stay tuned on that stream. What else? Zico. So Zico have done something here, providing long-lasting equipment helps with our mission to create a sustainable future. Engineers are the ones who do that. Thank you, Zico, for a great post there. Oh, I love this. These are robots. This looks like Uni of New South Wales again. Good work. I swear, I reckon these robots would go crazy on those robot competitions, but I know robots do a lot more good for our society than just bash up each other. So, and one last post that we've got here. Oh, help me here. Where is this from?
From the looks of it, it looks like a Scandinavian country of sorts. I would say Norway.
Sweet, yeah, Norway and England. Probably some sort of team activity going on here. Oh, yeah, and they've translated. Here we go. Walden emphasizes the importance of engineering work in supporting developing human welfare. It is important that there are engineers to design solutions and local challenges. There must be some sort of challenge competition going on.
That's right.
So, yeah, excellent. And I love their trackies.
That's right.
That's good. I think they're actually one pieces. That's even better. Where can I get myself a pair of those? I think we'd look very dashing in those one pieces.
The local Kmart, I guess. I'm going to
so.
have a look tomorrow.
Well, that's all we've got for the social media now. So I'll hand the desk back to you, Kartik.
Melanie, thank you so much for that. A lot of action happening on the social media boards. All of you, please do join us, worldengineeringday.net. That's where you can watch it. And of course, for those of us who want to be showcased on our social media posts, hashtag World Engineering Day. And now, of course, I'm going to let Mel go, but we have to move on, and it's time for a hackathon. That's right. And before we move ahead, there's a short promotional video that we'd like to show you. Time to get back into World Engineering Day, the great global hackathon. That's right. Now for our next entry. Our next finalist is again from India. It's Team IDIS from the University of Technology and Science in Odisha.
Hi, I'm Anup Paikre.
Hello, I'm Praktisha Sarangi.
And we are Team Indus. We are very honored to have been selected as a finalist in the World Engineering Day Hackathon in 2022. Now please enjoy our entry about P-Free. We work in incentivization of garbage collection. P-Free is an Android application that every individual can download and use to help clean up any rubbish that crosses their path. Have you done this at least once, right? And also this, it is called littering. I also used to do it, and millions of people are still doing it, not knowing its damage to this earth. The plastic that will litter in the road end up in landfills, which degrade the soil and produces more than 100 million tons of methane emission in the United States alone. And the plastic that end up in rivers or canals reaches the ocean, killing around 100 million aquatic animal every single year. Our solution briefly, an Android application that incentivizes public hygiene. So as you can see, just you have to enter your email ID and password. Once you are done with that, you will come to the main page. So here you can see I have put my email ID and I have put my password. So in the main page, you will see this type of image. This is for creating awareness, and if the users see this frequently, slowly and steadily, this type of message will get into their mind. And every time you open, you will get a different message. On the top, you can see the graph. It shows that how much scan you have done on the monthly basis. Now, as you can see, there is a small logo of dustbin in the screen. These are public dustbins or government made dustbin. So here is an example of what is a public dustbin means. So for example, if you have an empty packet of chips, now all you have to do is open your Android application, P-Free application, see the nearest dustbin to your location, and you have to enter within the 5-meter geofence. I repeat, the 5-meter geofence or the virtual radius of the dustbin, which is already being geotagged by us. The moment you enter within the 5-meter geofence of the dustbin, a scan option will be available to you. As you can see in the screen, a scan option is now available. After that, all you have to do is scan the wrapper, and then a reward will be given to you in the next 24 hours in form of coupons or vouchers. The work of the P-Free app is that to bring the user as close as to the dustbin, making him motivating him to throw the wrapper into the dustbin. So this has been done with our technique. Now, as you can see in the reward system, you can see all your coupons and vouchers that you have on, and we are creating a habit over the time, slowly and steadily. As the user keeps on going there, it will form a positive habit of maintaining public hygiene. Here's the leaderboard feature in which you can see your rank as well as the rank of your teammates and people who are using the P-Free. And our final feature is the community, in which you can talk with all the people that are using the P-Free in your locality. You can talk with them, you can discuss matter, you can raise, you can issue with your local municipality, you can report illegal dumps, and also you can plan to have the next cleaning campaign, all in this one. We created P-Free in respect of all the environmental activists who came before us, and to guide those who will come after us to create a better world. We need your support in nourishing the next generation of eco-activists together with P-Free.
That was Team IDIS that's trying to engineer good social behavior. And now time for the next entry. Something close to my heart. This one is from Monash University here in Australia, and it's Team Ruby.
Hey everyone, my name is John.
I'm Gilbert.
And I'm Aiden, all from Team Ruby, and we're super excited to be selected for the finals.
For World Engineer Hackathon 2022.
Please enjoy our short video about our cost estimation device.
Hello everyone, and happy World Engineering Day. Representing Monash Australia through Team Ruby, our project centers around real-time cost estimation of household electric heaters. Arguably, one of the largest sources of energy waste within a home is the heater, especially in those colder months, where many of us can leave it on and not understand the costs. With this, Our mission is to inform and remind our users of the costs that can come with leaving such a device on, and enable the users to make an informed decision concerning their power consumptions. Originally, our project was inspired by the desert tortoise native to the North American continent. Utilizing its burrows to regulate its evaporative water loss and body temperature so as not to lose unnecessary amounts of water, the tortoise saves a key resource in their environment. Comparably, our device is intended to enable our users to monitor the real-time energy usages of their home heaters so that they may avoid the needless waste of energy and associated costs. The way this information will be provided to our users is through a device that makes use of an LCD screen and simple speaker system, through which a real-time cost estimation and alarm is given. The data required to determine said costs will be gathered through the use of components such as temperature sensors and GPS, both of which are to be powered by lithium-ion batteries whose charging intervals are extended with the use of thermoelectric generators that utilize any available heat.
The mechanical details of our product will be further explained in Vietnamese, followed by Mandarin explanations of its electrical aspects. Mechanical component. Để tạo ra sự thông thoáng giữa bộ tản nhiệt bên trong và các bộ phận điện, đòi hỏi một thiết kế không gian rộng. Những tấm tản nhiệt lớn này là yếu tố cốt lõi để cung cấp sự làm lạnh thụ động cho nguồn phát. Để tránh tiếp xúc nhiệt ở mặt lạnh, in 3D kim loại có thể được sử dụng. Nó cũng sẽ làm cho sản phẩm bền vững và chi phí tổng thể do việc sử dụng công nghệ sản xuất bồi đắp này. Việc lựa chọn kim loại thép tạo ra sự cân bằng giữa độ bền kết cấu và các đặc tính về nhiệt. Tuy nhiên, đi kèm là sự bất lợi về hệ số giãn nở nhiệt cao, dẫn đến việc thiết kế ngầm kề phức tạp. Điều này có thể được giải quyết với thiết kế sáng tạo, tạo mẫu nhanh và công nghệ in 3D của thép duplex. Vị trí của thiết bị so với nguồn nhiệt sẽ ảnh hưởng lớn đến chức năng khởi động và cảm biến nhiệt độ tự động của thiết bị. Hơn nữa, dòng khí trong phòng sẽ tạo ra nhiều nhiễu động không mong muốn trên cấu hình nhiệt của các tấm nguồn. Chúng tôi đề xuất một quy trình tinh chỉnh để xác định khoảng cách tối đa từ nguồn phát nhiệt và sự xác nhận bằng mắt về việc hiệu chuẩn thành công khi thiết lập thông qua màn hình LCD. Cần đặc biệt lưu ý giữ nhiệt độ vận hành thấp do tính chất nhạy cảm của thiết bị điện tử, vị trí của các cảm biến nhiệt độ bên trong và vị trí lắp đặt của các bộ phận này sẽ cần phải tránh xa nguồn nhiệt trực tiếp.
Electrical components 5伏的电压是促成 USB 充电的标准。此外，5伏的电压也足够供电给所有与电池并联的外围组件。这是为了充电源能够同时运行负载和给电池充电。开启主电源后，液晶屏会向顾客显示操作模式，过后产品内置的 GPS 会定位所在地，然后单片机会根据 GPS 所定位的地区计算实时的平均电费。顾客可以在主页面选择所想要的操作模式，例如成本、温度，又或者是时间的最大上限。当顾客选择模式后，计时器就会开始计时。因为电池充电需要调节电流和电压，所以需要串联电压调节器和低功率热传导发电机。如果只是单单使用2颗2600毫安的电池，产品只能运作 2.1 天。但是如果加上热传导发电机，产品能持续运作 73.3 天。
In Melbourne, Australia, the average monthly temperature ranges anywhere from 6 to 26 degrees Celsius, meaning around half the year averages below 15 degrees, with drops below 10 happening even during summer, making the usage of electric heaters very common. Our device is estimated to save roughly $243 Australian per year if heater usage is reduced by 2 hours a day. The total cost of prototyping this device is $164, excluding 3D printing, and could be taken on as a final year project, meaning that the respective university may front the costs.
We thank you for your time, and we hope that you have enjoyed this infographic video by Team Ruby.
Glück auf! Hello, my name is Jürgen Kretschmann and I'm the president of TH Georg-Agricola University in Bochum, Germany. We are proud to support WFEO and all engineers who build our world back wiser. Our university is committed to support the Agenda 2030. We enable young engineers to strive for new ideas in order to achieve the 17 Sustainable Development Goals. For me, it is very important that our students and employees think and act in accordance to these goals. They are anchored in the self-image of our university. But we should not just leave the status quo to the next generation. That is too defensive. Engineering for a better world, that should be our claim. As engineers, we can positively change the world with our knowledge and skills. We can develop solutions for the challenges of our time. Together with the engineering community, we celebrate the World Engineering Day 2022 today. To all you talented young engineers, take your chance and make our world a better place.
Take your chance.
Toma tu oportunidad.
Saisis ta chance.
Hello, my name is Dr. Sunil Maharaj, and I am a professor and dean at the University of Pretoria in South Africa. The GEDC is a collaborative partner with WIFIO. As the chair of the Global Engineering Deans Council, it gives me great pleasure to partner with WIFIO for the 2022 World Engineering Day series of events. The GEDC has members from 6 continents, and its work is strongly aligned to the 17 Sustainable Development Goals, and we are encouraged by WIFIO's theme of Build Back Wiser, Engineering the Future. Please join the WIFIO 2022 event, and best wishes from the Global Engineering Deans Council for the World Engineering Day on 4th March 2022. Thank you.
Welcome back to the studios, ladies and gentlemen. That's right, it's been an action-packed few hours and we've got a few more to go. But we are going from coast to coast and from one part of the world to another. Let's move over now to our live hub in Ghana to see how the festivities there are going. They seem to be doing something that's action-packed and very, very exciting. So let's move over to Kwame Nkrumah University of Science and Technology. Over to you guys.
Our core business as a university, and I mean the College of Engineering, is to train students. And in order to train students, and I mean top-notch students, we also need good professionals and good human resource. And in that wise, we are very much concerned, and myself as the provost, very much concerned about getting top-level professors to help in teaching. So we first take the training of our professors very seriously.
The wear is severe enough to deteriorate and cause a downfall in the performance of the device. And we are doing it using a software called...
We also want to concentrate, especially on the students. And as we concentrate on the students, we are looking at what the teaching and the teachers will bring us. And we are also looking at what we can help in terms of laboratory equipment. Our labs are fully equipped. We have petroleum laboratories, we have autotronic, we have mechatronics, we have chemical engineering laboratories, and we have laboratories for all the 15 disciplines of engineering that we undertake.
At my young age, I started developing the passion for electronics. That passion I had, I'm still working on that passion to develop that passion up to today. And then that is the reason why I'm in College of Engineering, KNUST, to fulfill my dream, to work on my passion, and then see how I can help my community grow better. When I got to KNUST, we have opportunity to have access to all the labs around the faculty.
We want to make sure that in addition to the presence of laboratory equipment, we also give them support in terms of software training. Because in engineering, once they get out of school and they get into the field, we want to make sure that they have the expertise in the use of most of the current softwares which they need in their training.
Some of the projects that our students have worked on, for instance, in one of the courses that I taught, I gave them the challenge of going out there to identify a problem and then come up with a solution. Some went out there and came back with the problem of how to develop an intelligent basket. An intelligent basket solves the problems of long queues as far as the shopping mall is concerned. So that as people are shopping and they are dropping their things in the basket, automatically the basket is able to calculate how much they are supposed to pay, and then at the desk they give out their money and they are gone. And that is able to shorten the time as far as marketing is concerned.
Everyone is actually looking for a job, not to create a job. But College of Engineering is actually giving me the opportunity to create a job. Even before finishing my education here, I have my company already that I'm employing people, and we are working together, and then we are creating more jobs for other people to join. We are not waiting for the government or someone to create a job for us.
Going through the 4-year experience of computer engineering here, it equipped me with some skills that made me productive after school. And after school, I've been able to start a business on my own. I work as a computer programmer, and I'm also furthering here in KNUST. My master's, I'm doing MPhil computer engineering. I now don't have to wait for someone to employ me, but on my own, I can do things. I develop software, mobile apps, websites, web applications, and things like that on my own.
We are also very mindful of the soft skills that the students must have. And with this, we are looking at entrepreneurial training. And we have programs and individual standalone subjects which train them in entrepreneurship and innovation. And in this line, we have students who have gone on to do a lot of practical things. And one such innovation is a student and a group of students who are able to do 3D printers. And we also have students who have been able to manufacture an integrated circuit, that's an IC, which was done in collaboration with Texas Instruments in the US.
We can also buy 3D printers from outside, but they are really expensive. What can we do from what we are learning from school? What we can do is to make the theory we are learning from school to practical. Then the practical is what we are now doing in labs at the College of Engineering. I used to sell 3D printers online, advertising, but just mouth to mouth. When people contact me, I just have a page on Facebook.
The school did very well in helping me broaden my scope and give me a lot of options.
We want to train complete students. And if I talk about complete students, we want to train students who are good in theory, who understand theory. We want to train students who are good in practical. We want to train students who are innovative. And we also want to train students who are good in research. So we are taking them through basic research methods. We are taking them through startups and how they can dominate in their various industries by virtue of an understanding of the things that they do and the things that they've been taking through.
The Ghana Institution of Engineers has succeeded in leading engineering professionals and engineering development in Ghana. The story has been written and told in many facets, but let us do it the GHIE way this time, as we celebrate today's World Engineering Day. This is the second segment that focuses on professionals in engineering in Ghana, as we also interact with them in action. We will later on delve into TCC's upgrade to a UNESCO Category 2 center, as it is one of KNUST's institutions of technology transfer. It is still the World Engineering Day. Stay tuned.
So welcome to the World Engineering Day, a day set aside to celebrate engineering. You know, engineering is not only about design in the office, it's also about field work, and there's a lot of activity at various construction sites. We are now at the site of the Traco Plus. We are building this NOVA project, which is a building residential property, and it shows you the kind of things that go into engineering in the field. You are talking about the designs which is used to do the construction. You are talking about building materials and the specifications of these building materials. You are talking about workmanship, craftsmanship. You are talking about supervision of the project and the entire management of the project, so you get value for money. So those are the kind of things that are employed on a building site like this. And with me here, you have the project manager, Engineer Asari. He is responsible for taking charge of this site and making sure that this project goes according to the designs and the specifications that were employed.
This is NOVA, development by Traco Plus. It's a multi-purpose building with all recreational facilities attached. We're doing 150 plus units, a mixture of studio apartments, 2-bedroom, single units, 3-bedroom. It's a blend. And then a lot of shops beneath for all purposes. We started somewhere in 2019. COVID came along and we had to take a long break, but we resumed. Hopefully, in the next year, we are expected to complete and hand over. So far, everything is on course, and we're building according to specification, according to design. It's been reviewed a couple of times, but we're building according to what the consultants are asking us to do. Briefly, that should be about NOVA.
Right, so with projects like this, other critical things, in addition to quality, you want to build safely. You want the construction to be as safe as possible, not to injure the workmen or the public. You also do not want to damage the environment. And these are all considerations for major engineering projects, including the Pokwase interchange, the airport projects, the port expansion, and just name it. You just need to make sure that you take care of safety issues and environmental issues as well. I hope that you have a nice celebration, and thank you very much from the Ghana Institution of Engineering. Have a good day.
This is the kind of system that we are actually implementing now in Ghana.
Ernest Mate is leading an innovation revolution in Ghana.
Okay, 10. Push it more. Okay.
As co-founder of the Space Systems Tech Lab at All Nations University, Ernest harnesses the power of satellite technology to solve problems on land.
Our inspiration is the United Nations Sustainable Development Goals, and we try to create projects that should be able to achieve some of them, like quality education, well-being, quality water. We have projects where we measure air pollution.
This trailblazing attitude is something he's trying to pass on to the next generation through STEM programs.
My passion for STEM project is because I love teaching kids. So he's going to launch you onto the system, and then you feel like you are in space. Okay.
Ernest is integrating virtual reality into his programs, something he hopes can be implemented across Ghana.
Can you see the screen? Okay, you said that you are now on board.
Yes.
All right. International Space Station. So your mission is to inspect damages on the International Space Station. You know, virtual reality technology makes you feel like you are somewhere you are not. So what we are doing is that we are programming industries in Ghana on one system. Can you grab the other yellow one? Have you seen there's another yellow one? Yes, grab it. So you put the headset on, and then you can experience so much through virtual reality. It's either you are walking in space, you are learning human anatomy or dissecting a human body, You can do so many things. And we are doing all this just to complement the educational system that we have so that the kids are not only stuck to their books, but then bring technology to the classroom. Let them learn through the technology. We are trying to use virtual reality technology for her to begin to learn medicine. But she can use virtual reality it will become more real to her.
I think that technology is very good because it helps people to learn different things easier and better so that they can have better understanding about it.
In line with its mission to provide world-class airport facilities and services for the benefit of its stakeholders, Ghana Airports Company Limited has embarked on several projects. One of such projects was the construction of its new terminal, Terminal 3. The objective behind the construction of the project, among other things, was to attract more airlines and create capacity to enhance business at Kotoka International Airport. The new terminal has capacity to handle 5 million passengers annually and process 1,250 passengers per hour. It has 6 passenger boarding bridges, 3 business lounges, a commercially important passenger terminal, a dedicated road network, and a fully automated baggage handling system. To complement the new Terminal 3, the southern apron, which is the main apron serving Terminal 3, was reconstructed to receive the new passenger boarding bridges. This has an asphalt apron with concrete insets that extends to the taxiway. The regional airports, namely Kumasi Airport, Tamale Airport, and Ho Airport, have also had their share of construction projects. The construction of the new terminal at the Kumasi Airport is underway. The terminal is comprised of 3 passenger boarding bridges and 3 aircraft parking stands. It also includes an extension of the runway to accommodate bigger aircrafts for international operations. An aeronautical ground lighting system was inaugurated in 2014 to allow for night operations. At the Tamale Airport, the runway has been reconstructed to increase the length of the runway, which places it in the highest categories of runway, code 4F. It can therefore handle wide-body aircrafts such as A380 and Boeing 747. The construction also made provision for aeronautical ground lighting system for night operations. This puts Tamale in the position as an alternative airport to Kotoka International Airport in terms of aircraft operations. A new airport has been constructed in the Volta regional capital of Ho. The airport has a new terminal and a runway to serve smaller aircraft for domestic operations. As has been depicted in the video, engineering in the aviation industry cuts across many disciplines in engineering, including civil engineering, electrical engineering, mechanical engineering, electromechanical engineering, aerospace engineering, aeronautical engineering, computer engineering, telecommunication engineering, among others.
Ghana, as a member state, is one of the countries that sponsored the declaration of the World Day for Engineering for Sustainable Development. We sponsored this declaration because we believe in the importance of engineering and engineers in achieving the Sustainable Development Goals. Engineers are vital for all of man's basic needs and beyond. In the areas of health, in the areas of our basic needs, transport, etc., we find that we need engineers. This year's theme, Build Back Wiser, Engineering the Future, is particularly relevant. The world is just emerging from the throes of COVID-19, and we know how we have suffered. We didn't have the right infrastructure, hospitals, etc., to deal with the menace. It is important now that we are rebuilding to not just go back to repairing, but to make our world fitter and readier for any such pandemic. It is important to consider disaster risk reduction and also to use new technologies as we engineer for the future. It is important to have traditional engineering, but with new technologies added to it. So we are building back, well, you are building back wiser. Category 2 centers under the auspices of UNESCO are centers of excellence in their designated fields. We are very proud as a country to have one of 2 centers of excellence for engineering in Africa in the institution of the Technology Consultancy Center of the Kwame Nkrumah University of Science and Technology. It's a new center, but I know and already the rest of the world has shown a lot of interest in it. What we see the TCC doing is being a bridge between academia and industry. And that technology transfer is very important. If the work of engineers had to get to industry and transform our country, then we need organizations like this. We look forward to your work impacting not just Ghana, but all of Africa. In February, we celebrated the International Day of Women and Girls in Science. And building on that today, I'd like to advise the young ones, especially the females, to venture into engineering. It is a profession that needs young women because we have been told that young women are more stable in professions and only females can solve female problems. If we are to develop sustainably, then we need young people, young females in these professions, and not just in the popular ones, but also in others such as hydrogeology, geomatic engineering, and the like. It is also important that young people venture into engineering because in them we have brilliant minds who will be able to apply new technologies to basic engineering and help us build our world better, wiser, and more brilliant. Only they can help us do it. Thank you.
The TCC was created in 1972 to serve as an interface between the university and industry. And over these 50 years, the TCC has had a major impact on the grassroots industrialization of the country. This impact has been so significant that almost all major international development agencies, including the USAID, ODA, which now is called the DFID, the CEDA, the GTZ, which now is called GIZ, the IDU of the Commonwealth Secretariat, and Oxfam have all collaborated with the Center on various initiatives. In the year 2004, the center was placed under the College of Engineering at the university. And within the constraints imposed by this, the center has been able to make further progress in the area of student training. The center pursued initiatives that strengthened and complemented the core functions of the academic departments of the university. For example, on an annual basis, the center receives and distributes among its small-scale industrial partners an average of 30 KNUST engineering students as interns. The center at the moment is also collaborating with the Royal Academy of Engineering, UK, to develop manufacturing skills of final year students and recent graduates of Care University, as well as in 4 technical universities across the country. The reason for applying to undertake this project is to put in place programs to help address engineering skills shortage in Ghana by developing local capabilities in design and manufacturing of machinery through practical projects. The goal is to demonstrate engineering's role in driving economic development by increasing the employability of the engineering students and graduates and closing the skills gap between academia and industry. And a vehicle for establishing these programs is the project we call Manufacturing Hub for Closing the Skills Gap Between Academia and Industry, and it was supported by the academy. The main objectives were to help the students to realize locally designed manufactured prototypes, ultimately to commercialization, and also to help in improving the curriculum by sharing courseware and also by providing industrial internships to at least 32 engineering students per year, and also completing academic secondments to industry and training some of the students in how to set up, program, and operate CNC machines. We further train the students in areas such as entrepreneurship, as well as giving them hands-on practical training in industry. One of the aims is also to institutionalize this multidisciplinary cross-institution industrial capital projects in the engineering programs in all the participating institutions. A fourth objective was to increase access to research infrastructure in all the institutions that are participating in this project. The success of TCC's story has been to such an extent that the government of Ghana, through the Ministry of Education, fully supported the center's application to become a UNESCO Category 2 Center of Excellence in Engineering, Innovation, Manufacturing, and Technology Transfer. In fact, the General Conference of UNESCO, during its 41st session in Paris in November 2021, approved Ghana's application for the designation of the TCC of Care University as a UNESCO Category 2 Center of Excellence. This designation makes the center the first of such centers in the field of engineering in the whole of Africa. Now, the center's activities as a UNESCO Category 2 center is supposed to be regional in scope, benefiting Ghana and the whole of the West African sub-region. The goal of the new TCC is to be unsurpassed in excellence, adaptive research and development, technology innovation and transfer, manufacturing skills development, and impactful entrepreneurship development. The specific objectives of the new center are to, 1, undertake collaborative research to develop and transfer innovative engineering solutions and manufacturing technology for the sustainable development of the West African region and beyond. 2, to provide space for product development, dissemination, knowledge uptake, and to facilitate continuous professional development in relevant areas of engineering and technology within the West African sub-region. We also want to provide technical assistance to improve the competencies and also promote standards in manufacturing and technology. We also want to inject modern automation into indigenous manufacturing and industrial practices, as well as, finally, to develop policy briefs to inform and influence national and sub-regional policy direction on engineering, innovation, manufacturing, and technology transfer. And in doing these activities, we shall partner UNESCO and the government of Ghana. The TCC was created in 1972 to serve as an interface between the university and industry. And over these 50 years, the TCC has had a major impact on the grassroots industrialization of the country. In the late 1980s, the TCC started what we call the Intermediate Technology Transfer Unit at Swami Magazine in Kumasi. And it was a model of technology transfer from the university to the industry. The concept was so successful that the government of Ghana, through the Ministry of Science and Technology at the time, adopted the concept and replicated it in all the regions of Ghana. As we speak, this concept has devolved to the district level. And at the district level, they call them technology solution centers. And we are now retooling and re-equipping the unit so as to keep pace with the technological development in the world today. The Swame Intermediate Technology Transfer Unit has been our flagship unit. We have other sections, but that one has been our flagship unit. And through that, we have been able to make a lot of impact in the Swame Industrial Enclave and beyond. And we are hoping to upgrade it so that it can do even more.
We are one of the beneficiaries of TTC's impact, and we started working with them in the early 90s, starting with Honey Smoker, and we are now the leading gas oven and gas stove manufacturers in Ghana here.
We do some bushings for Caterpillar. When they are worn out, we replace them with new ones.
Each year, we are able to train over 10 students, female students from KNUST, and we are having over 42 working staff here.
The tech students, at least they bring us about 2 or 3 of them every year. We train them, we do whatever. Sometimes when they come, they only know the theory, but they don't know the practical. So when they come here, they see what they learn at school, they see the practical here. So it has been helping them a lot. Sometimes even when they finish, some of them even come back after schooling. They come back and continue their work here. So we have been helping them since about 4 years ago.
Welcome back to World Engineering Day, 4th of March for Sustainable Development. And of course, we've got some more finalists from this region, so let's get stuck into it immediately. Next up, we have our next hackathon finalists. They are the Wonder Pets from Batangas State University in Philippines. Let's take a look at what they've got.
Hi, I'm RJ.
Hi, I'm Gia.
Hi, and I'm Nicole.
And we are Team Wonder Pets.
We are very honored to have been selected as a finalist in the World Engineering Day Hackathon in 2022.
Please enjoy our entry about water remediation using metal organic frameworks derived from PET bottles. Our study aims to address SDG 6 and 12. Maraming salamat po and mabuhay! You've undoubtedly heard the term water crisis. Perhaps you have already heard that 2.4 billion people do not have access to basic sanitation facilities. First, 80% of the wastewater generated by human activities are disposed into the bodies of water with no pollution remediation.
Toxic pollutants from numerous sectors have made their way into many water sources today. We need potable water to drink and to bathe, as well as to irrigate our lands and feed our pets and livestock. SDG 6 is more important than ever for humanity's survival, as water is to life and it affects us in a variety of ways.
Despite the fact that water treatment technologies are used in industries, several of these have drawbacks. Among treatment methods, adsorption is found to be most effective due to its low cost, simple, and efficient design.
However, conventional adsorbents have drawbacks that restrict their applications on a large scale. To address the limits of conventional adsorbents, we propose the use of metal organic frameworks or MOFs, a novel material explored for its potential in various environmental applications. We aim to use MOFs for the removal of a range of pollutants from wastewater to contribute to SDG 6. MOFs has what we call a breathing ability, which allows them to host guest molecules and push them out once external stimuli is applied. This ability allows it to remove a large amount of pollutants and to be regenerated and reused, making it sustainable for water treatment. With its novelty, its raw materials and production process still need improvement. How do we aim to address this? By recycling plastic bottles. With our knowledge in chemical engineering, we know that a certain component in plastic bottles can help us in producing MOFs in a less expensive and more environmental friendly way. Over 3.8 million tons of plastic bottles are produced yearly, and only 7% of this are recycled, leaving the rest to pollute our waters and lands and affect wildlife. Repurposing them and giving them second life as protectors of our environment will contribute to responsible consumption and production, which is also another SDG we aim to address.
As a chemical engineering students, we developed a novel approach in the production of MOF adsorbents in a way that reduces costs, eliminates toxic reagents, and minimizes energy requirements. MOFs are composed of metal ions and organic linkers. To reduce cost, we use PET bottles as the source of our organic linker called TPA. We applied green method in extracting TPA from PET bottles through microwave depolymerization. TPA is non-dissolvable in water, requiring the process to use toxic organic solvents and extreme conditions to form MOFs.
Applying our engineering and chemistry knowledge, we converted TPA so that it readily dissolves in water.
This method enabled us to prepare MOF using just water as solvent and ambient conditions as opposed to conventional methods.
We successfully produced MOF in this novel approach and use it in removing dyes from water through adsorption. Aside from dyes, MOFs can also be used for the removal of pollutants like heavy metals and organic contaminants. Using our knowledge in separation principles from chemical engineering, we further improved the adsorption process using modeling, analysis, and optimization with the help of tools like Design Expert and Origin. The MOFs we produce cost a lot less than commercially available ones. 1 gram costs us only about $4 to make compared to $67 available MOF in the market. The total estimated expenses in this project is only $500. We aim to get funding from partnerships with different universities and government institutions. We would want to further collaborate with industries in the nations in order to pilot test our technology in an operational wastewater treatment plant. State institutions may also be involved to safeguard the program's long-term viability by providing support for policy formulations for water pollution prevention.
There's a lot to learn about MOFs. Aside from PET bottles, other PET-containing waste may be investigated, and metal scraps may be utilized as a metal precursor for MOF synthesis, which will be a part of a greater research that will be completed in a year or two. We researchers want to work with several organizations to investigate MOF as a 3D material. 3D printing offers another level to MOF manufacturing in terms of customizability, speed, and reusability in large-scale treatment.
Our team, Wonder Pets, hailing from different cities of Batangas Province, Philippines, came and worked together in crafting our solution on water remediation using MOFs derived from PET bottles. Targeting both SDG 6 and 12, our solution aims to merge waste valorization and value adding with the challenge of clean water and sanitation. Through waste recycling, we aim to build back wiser. And through water remediation using MOFs, we aim to engineer a better future.
Welcome back to World Engineering Day, and that was the entry from Batangas University in Philippines. And before we move on to our next entry, let me tell you what the prize money is after all. All the students who have entered will be fighting for the top prize money of 4,000 euros. The second prize is 2,000 euros and the third prize is 1,000 euros. But of course, the value or the euro value or the dollar value pegged to this does not tell us how important the work that's being carried out by these students across the globe. And of course, now time to move on to the next entry in our global hackathon, and it's none other than the team from Canada. It's the Team Mobile Rain Harvesting System from the University of British Columbia.
My name is Patrick Jillick Rodriguez. And I'm Ammar Zawahir.
I'm Wilson Holland.
And I'm Adam Friska.
We are Team Mobile Rainwater Harvesting System, and we are honored to be selected as finalists for the 2022 World Engineering Day Hackathon.
Please enjoy our entry about collecting rainwater to provide clean drinking water to Native communities in Canada.
That's how you'd expect to get drinking water in Canada, but for many Indigenous communities, that's not the case.
There are 35 long-term and 26 short-term drinking water advisories in Indigenous communities across Canada. This does not include private systems. Waters are contaminated with bacteria, chemicals, and/or heavy metals, depending on the community.
Water in these communities is regulated by the federal government, and not the provincial government, which applies to all other Canadians. So the water quality is not held to the same standard. Since 2016, the government invested $6.2 billion to solving this issue. However, this takes a long time because water treatment plants take 3 to 4 years to build. All the remaining water advisories are either do not consume or boil water advisories, so they're not safe for drinking, but they're also not safe for cleaning babies or elderly. So to deal with the dirty water, people must either boil the water or they have to get it in by trucks, which is inefficient and expensive.
The mobile rain harvesting system provides drinking water to households in Canadian Indigenous communities. As such, we are addressing UN Sustainability Target 6.1 by achieving universal and equitable access to clean drinking water for all.
Our product is designed to be retrofitted to a standard 250-liter rain barrel. The container is to be made of high-density polyethylene since it is safe, durable, and recyclable.
The system features a 10 square meter catchment surface, utilizing a hybrid polyester and polyurethane material that is supported by flexible metal rods for easy setup and takedown. This system will collect 15 liters per hour from rainfall. We are not using a rooftop system since debris and toxins from roofing materials can leach into the water. The flexible material of the catchment system can also be cleaned more easily, putting less stress on the ceramic filters.
First, the water passes through the mesh filter, which is used to remove large debris. Then the water passes through ceramic candle filters, which filter 1 liter of water per hour. Our system has 4 ports to attach a filter, meaning you can have up to 4 liters per hour of filtration flow rate. Of the many methods of purifying water, reverse osmosis, UV, ion exchange filters, and distillation, we chose ceramic candle filters for the following reasons. They are effective in removing bacteria, protozoa, viruses, and fine particles from the water. It also greatly improves the taste and smell of water. It is passive and operates under gravity. It is cheap, costing roughly $50 each, and must only be replaced about every 6 months. They are easily set up, cleaned, and are widely available.
A mechanical pump is mounted to the side of the container that will pump water from the clean water basin out of the barrel. The pump is the best option as it is cheap, can be replaced easily, and has little negative effect on the environment. In total, 1 unit will cost $550.
Our product does not require energy and is made of environmentally friendly materials. Mitigating the need for water trucks reduces carbon emissions. Our solution is inclusive because we are helping Indigenous communities which are often neglected due to colonization. Helping them reduces disparities in water distribution across Canada.
To make our project a reality, we would seek to build a few units using money from local competitions, funds from the university, and effective digital marketing. We could then find funds to manufacture a myriad of units to sell to Indigenous communities. This product can also be generalized and distributed all over the world. Everyone contributed to all parts of the project, but each member focused on what best suits their abilities. Patrick worked on the background research and worked with Amar to come up with the design. Adam made the CAD model using SolidWorks, and Wilson led the video production. Throughout the project, we kept in touch through Discord and scheduled in-person work sessions. We used PowerPoint presentations, sketches, and CAD models to facilitate sharing ideas. Thank you for watching our video, and a special thanks to the judges and organizers for their time.
Pakistan is a land of opportunities, a land rich of resources, cultures, and seasons. From hosting some of the highest peaks to vast deserts, with its beautiful people and rich heritage. A number of outstanding engineering marvels, including CPEC, various associated projects and industries. With evolution of engineering education, Pakistan is home to many renowned engineering universities, producing brilliant talent. Pakistan Engineering Council, since its inception in 1976, is contributing to sustainable development of Pakistan by making landmark achievements in all directions of engineering sector at the national and international levels. The governing body of PEC is the executive authority to deal with all the affairs and policy making for the entire engineering profession in the country, besides management committee and various other committees. Besides extending expert support to the government as a think tank, PEC has proved itself as a progressive organization at many international forums, like Washington Accord, Asia Pacific, WEFIO, OIC, and many more. And a prominent mentor for guidance on engineering education to Kenya, Saudi Arabia, and Central Asia on behalf of International Engineering Alliance and FIAD. It works in close collaboration with engineering universities and industrial sector, ensuring quality that meets international standards. PEC hosted many historical events for the betterment of engineering community, in which Pakistan takes immense pride. During the COVID-19 pandemic, PEC has made extraordinary initiatives as adaptive measures by boosting innovation, local product development, and entrepreneurship opportunities in the engineering sector by setting up Pakistan Innovation and Testing Center at PEC. To help PEC achieve its vision, its mainstream department, engineering accreditation, engineers registration, contractors and operators, CPD, think tank, along with supporting departments and offices all over the country, working in harmony, striving for excellence in engineering education and profession, with prime focus on the well-being of engineers of today and the future on every front at a global scale.
Welcome back to the studios, ladies and gentlemen. This is World Engineering Day for Sustainable Development. And now over to people that we can't get enough of. But for one last time, let's go over once again to the special country of Ghana and hear from Kwame Nkrumah University of Science and Technology.
Every little sin on earth has a beginning and an expected future. Our history of indigenous processes and inception of our engineering has been in existence for decades, even until now, even in the midst of new technologies. Don't forget that the context of Ghana's operations has over 80% of its economic activities stemming from the informal sector. This, I know, is how we do it in other spaces of Africa. These are everyday processes, re-engineered to reduce drudgery and improve performance the local and indigenous way. Our first stop is one of Ghana's biggest spare parts markets, situated at Swami in Kumasi, Ghana. They delve in casting, molding, and great replicas of any mechanical spare parts. Let's watch this.
We are one of the beneficiaries of TTC's impact, and we started working with them in the early 90s, starting with honey smoker, and we are now the leading gas oven and gas stove manufacturers in Ghana here. Welcome to Muntaos Engineering. This is Seidu Diawal Haq, the Managing Director of Muntaos Engineering.
We do some bushings for caterpillar. When they are worn out, we replace them with new ones.
Each year, we are able to train over 10 students, female students from KNUST, and we are having over 42 working staff here.
Sometimes even when they finish, some of them even come back. After schooling, they come back and continue their work here.
We will take you through the processes of how we do our manufacturing work here. Here is where we start the manufacturing process. So from here, you see the raw materials are on the floor and some are on the board. So we have to use the pattern and then we get the shape that we want. If it is oven that we're manufacturing, we have oven pattern here. And if it is stove, we are having the pattern. So what we do is we just mark everything either on the floor or on top of the machines. So from here, you see here is the cutting machine. So we cut it into the sizes that we want. So after here, we take it to this side, the bending side. That's where we get the molding and then the shape that we want. So from the bending side, we bring the materials here. Here is the assembling side. This is how the machine is being assembled. This one is a gas oven. So after assembling, you see it looking very nice. So from the assembling side, we have to go to where we lay the pipelines and then we check either there is no leakages in the oven or there is, so that we correct it before we take it to the finishing side. From the assembling side, this is where we fix the pipelines, and if it is stove, this is where we fix the burners and then we check all leakages. So afterwards, we go to the finishing side. Right here where I'm standing is the finishing side. You see on my left is the gas stove, and then you see the kind of powder coating we've used on it. So you can see from the manufacturing side, you see how the material was. It looks silver in color, but from here, you see it is dark brown. So we are done with the spraying. And then at the back here is the oven. You see there are silver sprays also here. So this is where we finish the processing.
Africa, with a low level of engineering technology inputs into agriculture, is one main constraint hampering the modernization of agriculture and food production in the developing parts of the world. Cassava, which is an important food security, industrial and energy crop in the world, has its roots providing dietary carbohydrates for over 800 million people in the world, with about 56% produced in Africa. Due to the slow and painful manual cassava harvesting practice in many parts of Africa, it has made cassava production unattractive to the youth. And now, from the Kwame Nkrumah University of Science and Technology, KNUST Kumasi, climate-smart planting has been introduced to farmers as they plant in rows and ridges. With a vast experience in agricultural development and mechanization, Professor Emmanuel Bobobi has invented the efficient tech mechanical cassava harvester, ideal for harvesting all tropical root and tuber crops. So before harvesting, farmers must first coppice. Make the height of the stem about a foot high, but has to be lower than the underbody clearance of the tractor to serve as a handle during harvesting. This is robust, durable, and easy to maintain. This will indeed help farmers to dream, work, and smile again to bounty harvests, as it has been tested in Ghana, South Africa, and other African countries.
One of the byproducts from the production of palm oil is the palm nut. Now, the palm nut has a seed in it which has some oil that, when extracted, is normally referred to as the palm kernel oil. Now, but this nut had to be cracked. And once it is cracked, the kernel has to be extracted from the shells before further processing can take place.
Ghana produces more than 51,000 metric tons of palm kernel a year. Although large or medium-scale mills produce 3,000 metric tons of palm kernel oil annually, only 25 to 27% of palm nuts are cracked and processed by the industrial mills. Using inefficient traditional methods, a large number of women oil makers in 7 of 10 regions of the country process 40 to 70% of kernels from the oil palm industry, supplying about 8,000 tons of crude palm kernel oil to edible oil consumers and additional quantities for local alata soap production. Disadvantages of traditional clay or mud bath. The clay technique uses large quantities of high-quality clay. It also uses large volumes of water. The separation process is labor-intensive. The efficiency of the separation is usually low. The cost of separation is very high. Given a projected national visible edible oil deficit of more than 100,000 metric tons, upgrading the process technology of women processors will increase their oil market share and income levels. Over the years, the Council for Scientific and Industrial Research, Institute of Industrial Research, has developed several mechanized engineering technologies to aid industry in their operations. These technologies have been installed across the country. Among these technologies is the mechanized palm nut cracker and kernel shell separator. It is designed to separate cracked palm nuts into various components. The designed concept was formulated based on solid material separation techniques. The concept focused on particles properties such as friction, both static and dynamic, size variations, and motions of particles, as well as factors that influence friction on a given surface. A truncated concentric two-ply sieve was used to automatically grade the material being separated into 2 grades based on size and, per the concept, improve upon the efficiency of separation. The kernel shell separation system combines both the winnowing and separation activities at a go, thereby saving the processor over 28 man-hours per ton of processed kernels. This saves a lot of man hours and reducing cost of production and high value byproducts. Let's also take a look at some of the advantages of mechanized palm nut cracker and kernel shell separator. The technology eliminates the use of water and clay in the kernel shell separation process. Kernel shell separation time is drastically reduced and there is high separation efficiency of about 80 to 90%. The technology is environmentally friendly, and also the technology produces natural shell pellets, which is high-grade solid renewable fuel for burning. Beneficiaries of mechanized palm nut cracker and kernel shell separators are agro-process equipment manufacturers, women operating in the informal micro-scale kernel oil production in both urban and rural areas, producers of activated carbon, and exporters of clean palm shell for organic farming.
African countries continue to grapple with waste disposal and management, a state impeding its developmental agenda. The continent produces thousands of tons of solid waste daily, with most ending up in open dams and wetlands, contaminating surface and groundwater and posing health hazards to majority of its people. In most African countries like Ghana, waste management is largely at the district, municipal, and metropolitan levels, where waste is sent to landfill sites which are gradually becoming difficult to manage technically. Compounding the situation is the non-availability of land for such purposes. To turn the tide around for the continent, Lancaster University, with her development partners 4 years ago, embarked on a project known as Recirculate, a circular economy in which waste and resource management contributes to a resilient environment and human well-being, making use of reduce, reuse, recycle, and repair or refurbish. The success of that project is what has led to the introduction of what it now terms as relating the adoption of circular sanitation demonstration systems for improved health outcomes, simply dubbed Actuate.
The Actuate project is designed on the premise of having to solve or contributing to 3 particular SDG. SDG 3, which is good health and well-being. SDG 6, which is clean water and sanitation. And that of SDG 7, which is affordable and clean energy.
This is a biogas setup which we have done for the school. So here, because it's a school, then we're looking at using the school waste, the one which can ferment. So you have this as the main engine, which is called the digester. This is only a demonstrational site for the school, but they can have bigger ones. Part of the curriculum and of the children at the SHS, you open your textbook, it is there. Renewable energy, and then they talk about biogas. So we're doing it with the school. The teachers are part of it, and then the students themselves are part of it. Right, so this is called a macerator. It's just like the blender, which is being used in the kitchen. It's for grinding the waste that we can. So let's say if you have leaves or it's, let's say, banana peels, we can't use the big size. It must crush it because the microorganisms that will feed on it are tiny. So where it is crushed, and then it is motorized. Once it crashes down here, we open this unit and then it will go through to a mixing chamber at this point. From this mixing chamber, then we will need to send it up there. So sending it up there means that we need to pump it to the extreme end, that is the inlet. Because up there you have the solar panel which takes the energy from the sun. The sun's energy must be converted to electricity. And this is the device that will connect the sun's energy into electricity, which then can power the system, the pumps. But then these are batteries, which then can store the power. Because when the sun is not shining, we still need some power. So the battery then stores the power so that then we can use it for our system. Okay, this is the end use of the gas. That is where the gas finally comes. You can either use it for cooking or you can use it for lighting.
Now, Atuate is talking about renewable energy. That energy is used for agri activities. The biofertilizer is used for agriculture. The fertilizer is used to produce foodstuff. The foodstuff is what we eat again. We eat, we generate waste. That waste is not waste, it's a resource in an Atuate sense. So it's in circle. So nothing goes to waste.
We all hear about climate change, but then how does climate change impact us and how do people know that it is really impacting our lives? So Atuate was featured as one of the local actions that was promoting climate change activities in our communities.
So far, Green Art has been able to renovate a space in the school into a show lab where the gas will be connected directly into. So as part of the training given to the students, we went through a couple of presentations to get them to understand what waste is, how they could segregate their waste at home, the types of waste they normally find at home, and how best they could bring it to the school.
We as students are asked to bring some waste products from the house so that they can be used to feed the biodigester. Told us that when we feed the waste products into the tank, it will process it into a gas so that it can use to power the science lab, the show lab over there. The digestate, which will be left inside the tank, we can use it to feed our crops as fertilizer.
I want to really congratulate the implementers of the project. Community consultations actually went on. That's the most exciting part of this whole project, because I realized that the implementers of the project had to meet religious leaders, both the Muslim, the Christian faction. They also had to meet opinion leaders, that's the assemblymen, the chiefs, and and the sub-chiefs within the community-based organizations, and then youth groups within the community through a deba, and then explain everything into details. They actually also did that using local languages, to explain the concept of the project. So everybody within the community knows exactly what is going on and what is actually going to come out of the project.
We hope you loved our indigenous ways of doing things. This has been the World Engineering Day from Ghana, Africa. I am Summer Wonder.
CSIR stands for Council for Scientific and Industrial Research and was established by the first president of Ghana, Dr. Kwame Nkrumah, in 1958 to organize and conduct research to support the development of Ghana. In its present form, it was re-established in 1996 to include additional mandates. And our mandates are to conduct research, transfer knowledge, advise government, coordinate science and technology research, and commercialize the research products. The mission of CSIR and the mission has been to look at how we employ the technologies that we develop in powering our economies and to support our industries. CSIR started with several institutes, and as of now, we do have 13 different institutes spread across the country. Right from Tamale with Savannah Agricultural Research Institute. In Kumasi, we have 4 of our institutes. In Eastern region, we have 2 institutes and 6 institutes in Accra. And out of these institutes, 70% are agri-based and about 30% are engineering-based. CSIR has well over 500 research scientists, and that accounts for the largest congregation of research scientists in any organization in Ghana. Over the years, CSIR has developed several technologies, and these technologies have ended up with our society. The food varieties that we have in Ghana, most of them are developed by CSIR institutes such as Crop Research Institute and Savannah Agricultural Research Institute. In terms of food products, again, we have some of our products in the market, like packaged foods, developed by CSIR Food Research Institute. Animal research has got several products in the market to support the Ghanaian economy. In terms of engineering, CSIR has come up with several engineering equipment and tools to support especially the agricultural industry. Recently, we have moved into emerging engineering technologies and the use of artificial intelligence in tracking moving objects, for which we are intending to apply to solve the problem of galamsey. Artificial intelligence being applied in solving ECG's problem of power theft that ECG is unable to resolve.
Ladies and gentlemen, after that inspiring presentations about indigenous practices from Ghana, we now move to one of the most significant and important portions of our program today. We are going to be switching live to the UNESCO meeting that's happening on sustainable development. And this is completely live with panelists who are going to be talking on how the UN's efforts are being geared towards building a better and a sustainable future. So without further ado, ladies and gentlemen, we are now switching over live to UNESCO.
A World Engineering Day serves as a reminder that we need engineers more than ever to meet the urgent needs for clean water and sanitation, resilience to natural disasters, increased food production, and protection of our oceans and land resources. This is why this day is an opportunity to highlight the crucial role of engineering in achieving each of the 17 Sustainable Development Goals, the SDGs. It shows how equal opportunities for all are essential to ensure the inclusive and gender-balanced profession in that all that can better respond to the shortage of engineers to implement the SDGs. It provides a snapshot of the technical innovations shaping our world, especially emerging technologies such as big data, biotechnology, and artificial intelligence, which are essential to address the pressing challenges facing humanity and the planet. It analyzes the transformation of engineering education and capacity building at the dawn of the fourth industrial revolution that will enable engineers to meet the challenges ahead. It highlights the global effort needed to address specific regional disparities while summarizing engineering trends in different regions of the world. The main problem facing the world today is how to reconcile human development and the preservation of the planet. This is why engineering of today and in the future need to adapt and respond to pressing global challenges. Ladies and gentlemen, the 20th century saw unprecedented progress in improving the standard of living for millions of people worldwide. Electricity gave billions light after dark. The internet connected continents at lightning speed. Transport evolved from horse and cart to space travel, and vaccines were developed for some of the world's biggest killers, with diseases like smallpox completely eradicated. These developments and thousands of others like them have transformed lives. Together, they have immeasurably changed the social and economic progress of humanity. We have engineers to thank for driving this process, this progress. But we are far from finished, and many more global challenges remain. Over 1.1 billion people still don't have access to electricity, 2.4 billion don't have adequate sanitation, and 663 million people lack access to clean water. Furthermore, about 1/3 of the world's population is not served by all-weather roads. Technology and infrastructure, both improved access to existing solutions and new innovations, they will be key to addressing these problems and enabling growth in trade, access to education and work, as well as increasing the productivity on a local, national, and international scale. But we also need to make sure that the actions we take are sustainable, that humanitarian measures build long-term self-sufficiency in the communities they seek to help, that they meet the needs of the growing population and minimize the pressure on our planet's resources. These are set to be the biggest engineering challenges for the next century. It's only by applying the best talent that we can meet all of these challenges and continue to improve quality of life and economic prosperity for generations to come. By the end, I wish you all a great meeting and a wonderful World Engineering Day of 2022. Thank you.
Thank you very much, Yes, for this inspiring talk. At the outset, I would like to thank you all for joining UNESCO Day to celebrate the third World Engineering Day for Sustainable Development. The theme of the day this year is Build Back Wiser, Engineering the Future. We are very pleased at the incredible number of requests for joining the event from all over the world. This shows how big the issue of engineering and sustainable development with regards to engineering education is globally. I would like to invite you all to share your thoughts via the chat and ask questions to our panelists via the Q&A chat box. Now I would like to start this by starting this round table discussion. What can we do to engineer the future towards the sustainable development goals? Ladies and gentlemen, I would like to start our roundtable today by introducing our very distinguished panelists who are experts in their fields and contribute to engineering education through different tools around the world. We want them to answer the question, what can we do to engineer the future towards the sustainable development goal? What tools are available? Our first panelist today is Dr. Marlene Kanga. Dr. Marlene is the immediate past president of the World Federation of Engineering Organization, WFEO, the peak body for engineering institutions and internationally preparing some 100 engineering institutions and approximately 30 million engineers. She's a chemical engineer. She was the 2013 National President of Engineers Australia. She is a fellow of the Academy of Technology, Science and Engineering in Australia. She is a member of the Order of Australia, a national honor in recognition of her leadership of the engineering profession. Dr. Kanga led the proposal by WFEO that resulted in the declaration by UNESCO of the 4th of March, the founding day of WFEO, as the World Engineering Day for Sustainable Development. She was the author of the first chapter of the second UNESCO Engineering Report, Engineering a More Sustainable World, which recommended the need for more engineers with the right skills for sustainable development. Thank you, Marlene, for that extremely interesting forum, which UNESCO is proud of to be part of. So now the floor is yours, Marlene, please.
Yes, thank you very much, Dr. Amal Kazri, for that very kind introduction. I'm really pleased to be here, and I'd like to wish everyone happy World Engineering Day. I'm going to now try and share my screen. Sorry, Yes. I hope you can see my screen.
Yes, we can.
Yes. So I'm going to talk to you about a new initiative that we're really proud to announce today on World Engineering Day, the WFEO Academy. And for this, I'll give you a little bit of background. As you said, the World Federation of Engineering Organizations is the peak body for professional engineering institutions. And we have some 100 national members from around the world and 12 regional and continental members, representing some 30 million engineers. And of course, we're an associate of UNESCO, and we co-chair the Major Science and Technology Group at the United Nations, and we represent engineering at all the other major UN organizations. A key objective of the Federation is to advance the UN Sustainable Development Goals through engineering. And we have been working with UNESCO, and I'm so proud to say, on many initiatives, but in particular, the successful declaration of World Engineering Day for Sustainable Development by the UNESCO General Conference in November 2019, while I was president of the Federation. And the UNESCO Engineering Report, Engineering for Sustainable Development Goals, aligns with this vision on how engineers can make it happen. And in addition, the report clearly shows that we need to build capacity for more engineers with the right skills, which is the topic of the discussion tonight. Chapter 1, as you mentioned, was authored by me of the second UNESCO engineering report. And in that, the recommendation was to increase the number of engineers, but also to ensure the quality of engineers to achieve the Sustainable Development Goals. And this can be achieved only with good engineering education that meet international benchmarks and that are recognized and form the basis of national engineering education systems to train engineers with the right skills, especially in Asia, Africa, and Latin America. And this is precisely what the World Federation is doing with its partners. Our journey began at our 50th anniversary celebrations in Paris in March 2018, when we signed a declaration with UNESCO, the first time WFEO had signed such a public statement with UNESCO. And in that, we committed to advancing the Sustainable Development Goals through engineering. And there were three major parts to this. First, to increase the number and quality of engineering graduates. Secondly, to inform the global standards for engineering education and support the development of national engineering education systems that comply with these standards. And thirdly, to support capacity building for strong institutions for engineering education. Under my leadership, we developed the Engineering 2030 plan, and there are 12 principles, but three major ones. The first was global standards for engineering education to be developed in partnership so that they meet contemporary needs. Second, the development of national engineering education systems that comply with these standards. And third, and most importantly, capacity building for accreditation bodies that accredit engineering education systems and for professional engineering institutions, and to develop professional pathways for engineering. And of course, these advance the three Sustainable Development Goals for education, Goal 4, strong institutions, Goal 16, to be developed in partnership with WFEO members, the International Engineering Alliances, and other signatories, and of course, UNESCO. And this encompasses Goal 17. We have had three projects in the pipeline in the last 2.5 years. Project 1 was to review the global engineering education benchmarks to make them more contemporary and to be able to have engineers that graduate in the future the capacity to incorporate the UN Sustainable Development Goals in their work. And this was completed in June 2021 and was published by the International Engineering Alliance with the support of UNESCO and the Federation in September 2021, and has been translated into 6 official UNESCO languages by another partner of WFEO, the ICEE Category 2 UNESCO Center based at Tsinghua University. And this will be published shortly. Project 2 is capacity building of national engineering education systems. And we have 2 projects in progress and the third about to start. And this includes Mauritius in the southern part of Africa, Kenya in Eastern Africa, and soon Ghana. Africa is very important because currently only South Africa is a signatory to the International Engineering Alliance. And we really need to address the standards of engineering education and also increase the numbers of engineers. Project 3 is the capacity building for engineering education with training at scale using advanced technology. And I'm proud to announce that this is the WFEO Academy. This is a new project that will provide on-demand training for engineering educators, for accreditation bodies and professional engineering institutions, and for engineers who have already graduated and are in practice to continue their professional development. And this is being done in partnership and supported by UNESCO, in partnership with the Global Engineering Deans Council, GEDC, the International Engineering Alliance, and the International Federation of Engineering Education Societies. And I'm so proud that this project also advances the UNESCO recommendations for open science. It uses technology to transfer knowledge and skills where they're needed most in Asia, Africa, and Latin America. The courses are available on demand at no cost to individuals who are members of the WFEO members and affiliate institutions. We have bronze, silver, and gold awards to encourage participation. Most importantly, this is an inclusive program. Engineers can access this at any time. It's a sustainable project because it uses existing content of webinars that have been done already by experts. So we're not using more energy. And it's translated into more than 100 languages. And I've shown here some examples: Arabic, Hindi, Swahili, which is spoken widely in Africa, and Spanish, of course, spoken widely in Latin America. So I hope that many engineers will take the opportunity of this training and get a huge benefit from it. Thank you very much.
Thank you very much, Marlene, for this extremely interesting forum. UNESCO is really proud with your partnership. Thank you very much. Now the second speaker is the Professor Fansu Khalid. Professor Fansu Khalid is a professor of civil engineering at University of Lagos, Nigeria. He was appointed the professor in 2001. He was head of the Department of Civil and Environmental Engineering and former dean of Faculty of Engineering at the University of Lagos. In 2002, Professor Khalid initiated the African Regional Conference on Engineering Education, which led to the establishment of the African Engineering Education Association. In 2006, in South Africa, he was the founding president and the current president of the association. He was a vice president of International Federation of Engineering Education Societies, and he is a member of the governing board of the International Center for Engineering Education, which is a UNESCO Category 2 center, jointly owned by Tsinghua University and the Chinese Academy of Engineering in China. In 2013, Professor Khalid championed the inauguration of the African Engineering Deans Council. Professor Khalid, the floor is yours.
Thank you very much, Rina, for the kind introduction. Happy Engineering Day to all of us. The title of my presentation is Engineering Education for Now and Beyond. Engineering education is the process of training engineers who are supposed to be the initiator, facilitator, and implementer of technological development of a nation. The input of engineers are crucial to the realization of sustainable development goals. The state of engineering education in Africa now can be summarized as follows. The training institutions are underfunded. Poor funding manifests in lack of teaching and research equipment, both in quantity and quality. Other facilities that are necessary to provide enabling environment for the knowledge dissemination and acquisitions are also inadequate. The student enrollment increases yearly because of high desire by prospective candidates to study engineering, but the resources required are inadequate to support them. There is consistent movement of highly trained professionals, intellectuals, talents, specialists in engineering from university to other professional callings because of lack of job satisfaction, mainly as a result of poor pay and salary erosion, as well as inadequate facilities for research to actualize their dreams. This movement has not only slowed down progress in engineering education, but also inhibit socio-economic and technological advancement of African nations. There is weak partnership between university and industry. Because of this, there are gaps between what the students are taught in the universities and what the industry requires. This results in high unemployment among the engineering graduates. The current engineering curricula are defective. They are based on foreign model, which has evolved under ideal conditions. And there is inadequate provision for humanities, social sciences, business management concepts, and entrepreneurship skills development. Most of the teachers adopt the traditional method of transferring knowledge to students. This is passive and as opposed to active learning, which puts students at the center of learning. Majority of teachers do not have industrial experience. Many students are inadequately placed during student industrial attachment programs. Women are underrepresented in engineering. The fallout from these inadequacies is that there is lack of engineering capacity in Africa and heavy reliance on imported expertise in engineering. Without proper engineering education, there cannot be production of quality engineering graduates from the training institution, and there cannot be any meaningful development. Beyond now, Africa needs engineering education reform. Namely, the curricula of engineering program need to be redesigned and tailored towards the achievement of the sustainable development goals. There is need for teachers to adopt innovative pedagogy method that puts students at the center of learning and ensure that students acquire capability for problem solving, innovative and entrepreneurship skills. The training must equip students with skills for international engagements and capacity to solve local problems. Close collaboration between industry and university should be pursued. Universities should be represented at faculty boards and be allowed to assist to review the curricula in line with the needs of the industry. Government or member states, as a matter of policy, should intentionally and proactively fund education at all levels, in general and in particular engineering education, being the gateway to sustainable development and poverty alleviation. Women should be encouraged to develop interest in engineering. Women, the engineering bodies, including the Africa Engineering Education, should continue to pursue their visions with serious vigor to promote quality engineering education in Africa. And currently, the Africa Engineering Education Association is working in collaboration with the International Federation of Engineering Societies, Global Engineering Days Council, to build capacity in engineering in Africa. With regional and sub-regional accreditation bodies should be established. This will enable universities in the region to benchmark their activities, including curriculum against standards that have been designed and agreed upon at regional level. This may also serve as a tool to force government to fund education with emphasis on engineering education. It will also facilitate mobility of engineering personnel within the region, thus stemming the unemployment among graduates. COVID-19 pandemic has necessitated the urgency to migrate to online engineering education. There is need to build capacity in innovative pedagogical methods in this digital era. The recently established African Research University Alliance will promote multidisciplinary and interdisciplinary engagement and fast-track the development of relevant endogenous technology that will be tailored towards achieving the sustainable goals. This alliance currently comprises 16 universities from 10 nations of Africa with a focus to collaborate in research. This should be expanded and strengthened. Thank you for your attention.
Thank you very much, Fansu, for this inspiring talk, and thank you for concentrating on engineering education in Africa. So now our third speaker is Mr. Vincent Kabunga. He's hands-on learning for STEM education and getting our new engineers abroad. So Mr. Kabunga is passionate about digital transformation, and he supports many initiatives to enhance digital inclusion and equity in Africa. He is a knowledge management and organizational development specialist with cross-training in engineering, management, and M&E. Vincent is a telecommunications engineer and a senior member of IEEE. He has worked extensively across Eastern and Southern Africa and in Southeast Asia. He has over 20 years of experience in sustainable development and organizational capacity development. He studied electrical engineering at Makerere University and pursued postgraduate studies in information technology at the University of Pretoria and strategic business management training at the Strathmore Business School. He sits on many IEEE societies. He has actively led and supported efforts on the ground that have been the formation of new IEEE sections, student branches, local technical chapters, and most recently, the IEEE Africa Council. Thank you, Vincent, for joining us today, and the floor is yours.
Thank you very much, Amal. And happy World Engineering Day to everyone. It's really a pleasure to be here today. And thank you to the organizers for this opportunity to share with you some insights on the work that UNESCO and IEEE have been doing to support the expansion of engineering capacity in Africa for the future of the region. As Amal has mentioned, I have had the honor of leading IEEE's work in Africa for several years. And as part of that, I've also been on the front lines of our work with UNESCO. IEEE, as you might be aware, is the world's largest professional association advancing technology for the benefit of humanity. We publish journals, sponsor technical conferences, and develop technology standards while supporting the professional interests of our more than 400,000 members across the globe in over 150 countries, actually. IEEE and UNESCO have been working very closely over the last 10 years to build and actually expand the local capacity in STEM education and to support STEM careers in Africa as we prepare for the future of the region. One of the sorry, just realized my slides aren't moving as fast as I thought they were moving. Okay, here you go. Yeah, so one of the most exciting programs that we've been working with is the REACH program. And REACH is a program of the IEEE History Center. It is supported by IEEE and the IEEE Foundation. REACH stands for Raising Engineering Awareness through the Conduit of History. The program provides open education resources for secondary school educators, and it aims to prepare secondary school students to be technologically literate. And we do this through the lens of history. This enables us to prepare the students to not only know what technology is and how it works, but also how it shapes society and how society shapes technology. REACH provides a selection of lesson plans on different subjects. We have primary sources of the materials that we are using that have been developed by IEEE, the History Center, hands-on activities, and a lot of multimedia resources that students are able to engage with. The goal of the program itself is to give the students a new lens with which to view technology that is relevant to their own lives and also look into the future. It's a new pathway to STEM education, enhancing student skills in problem solving, critical thinking, research, communication, and collaboration. It prepares the students to become better informed citizens of our high-tech society that we are building, and helping to improve technology and engineering literacy, while meeting the needs of secondary education teachers in both STEM and the humanities. We utilize the REACH program to implement a co-branded activity for IEEE and UNESCO in Uganda. This was with the assistance of the IEEE Africa Council, the IEEE Uganda section, and 2 local nonprofits. It was a pilot activity intended to introduce REACH to the local audience. And in this activity, the local organizations that we worked with did something quite amazing with the resources. They were able to adapt the materials that we have within REACH to meet national educational requirements of the education curriculum that is used in Uganda. And in addition, once that had been achieved, they then made use of a traveling classroom trailer to reach underserved communities that were really targeting to reach inside this in this pilot activity. And on completion, the activity itself had reached over 70 teachers and impacted over 1,000 students. The pedagogy that we employed in the activity utilized history of science. We were able to spark creativity. We boosted critical thinking, collaboration, teamwork, communication, which are all critical skills for folks that are pursuing engineering careers. The REACH resources allowed for very high levels of contextualization and relevance. And we found this a pretty exciting, and it was reflected in the results that we observed on completion of the pilot. As you can see, the activity was very well received, and results were quite impressive. Following on from the pilot, the Uganda National Commission for UNESCO then took this a step further after observing the value that the program had shown, and its potential to actually make some really big, impactful moves on the ground. Went ahead to convene stakeholders on the ground, including our IEEE network, of course, the UNESCO people on the ground, and the Ministry of Education. And this time, the objective was to actually focus on the teachers and get them to appreciate what this could do for the STEM education. Now looking at it from a national level, completely different perspective at this point. The teachers were inspired by participating and engaging in the REACH activities, just like students would. And through this activity, they were able to gain a whole new toolkit that they could use in their classrooms, and also developed a new STEM education pathway that they could use as they started to work on a new national curriculum rollout that is currently underway in Uganda. This actually led to an even more elevated interest in the activity. And we are now at the stage where we're looking at the National Ministry of Education having consideration for an expansion, a circular expansion of this program in the country to cover the science, secondary science teachers more comprehensively. What we have seen with this that we demonstrated was that we were able to link abstract concepts to real life situations and engage people in hands-on activities. And this was quite, for us, quite amazing, because we were working with a lot of folks that we typically refer to as underserved, and perhaps they haven't had the kind of exposure that many of us have become accustomed to. But we were able to see them positively respond to this, and we were really excited by where this is going. And we are really excited that everybody has been a part of this journey has really been inspired to take this to a different level. And we are hoping to see this program continuing to expand across Africa through the network of the science and math teachers networks. And I'd like to stop here for now, and we'll be happy to take any questions later. Thank you very much, and back to you, Amal.
Thank you very much, Vincent. Thank you we are all thrilled at UNESCO here. Thrilled to have worked with the IEEE on the REACH project, and we look forward to expanding the project to different countries together. Thank you very much. Our next speaker is Ms. Nadia Musaji, and she will talk about integrating our young women in Africa, what is in store. Ms. Nadia Musaji is a serial entrepreneur by passion. She's an engineer by training. She is also a co-founder at WOM Hub, a boutique incubator supporting females all along the STEM value chain from attraction to ownership. She serves as the chief innovator, with her focus being gender lens on entrepreneurship, AI, and cybersecurity. Nadia co-founded WOM Eng, which is a global social enterprise developing women and girls for engineering and tech. She is a venture partner at 535 Ventures, investing in women in tech businesses across Africa. Nadia also co-owns a successful restaurant group and was named top 20 young power women in Africa by Forbes and an Aspen Institute New Voices Fellow 2019. Nadia has worked across 24 countries to revolutionize the face of engineering through diversity, inclusion, innovation, entrepreneurship, and education. She is passionate about equitable technology, fostering prosperity in emerging economies, and engineering better societies. We are very proud of you, Nadia, and thank you very much for being here with us today. The floor is yours now, please.
Thank you so much, Amal, and to the team at UNESCO for hosting this. And again, as a very proud engineer, happy World Engineering Day to everybody. For those engineers, those support engineers, and those who'd love to be engineers, it's a day of celebration of who we are, what we can achieve together. Today, I've got the honor and the pleasure to speak a little bit about the work that we're doing at WOMENG to support young women and ignite the engineering ecosystem. And so we always see STEM as an opportunity for growth, development, for change, for creating better societies, creating more equality and equity. But that doesn't happen on its own. It happens because we ensure that our engineering industry is diverse, that it's equitable and it's inclusive, to make sure that we have the innovative people who are able to create these very diverse solutions to what we call the wicked problems in the world. And those are the SDGs. And we've always fundamentally maintained that the SDGs are only going to be achieved, and the SDGs are basically engineering problems that need to be solved, and we need diverse engineering teams to solve it. And so what we do at WOMEB is really around diversity and inclusion for the engineering and tech industry, but making sure that we work all the way along the pipeline from attraction to ownership. And what we do is really around how is it that we make sure that we're attracting young girls and young women into the engineering and tech industry. We do support not just a bottom-up approach by getting more girls excited about engineering careers, but also a top-down approach by working with some of the largest engineering industries and companies around the world to be able to understand why inclusion and diversity is important, not just for the bottom line, but also to breed and foster innovation. And we do this through a lot of experiential learning and training and rethinking the education models in which we train engineers and future engineers as well. And so, the work that we've been doing over the last 17 years at WOMEN just really come to a conclusion that it requires an entire ecosystem to create the change. It's not enough to just get more girls inspired to study engineering. It's not enough to get university students to kind of foster new ideas and get into kind of new technology industries. It's not enough to support women entrepreneurs in the industry to be able to create better role models, but also create better solutions and economic development. We actually need all of it. And we need all of it now. Actually, it would be nice if we did all of this yesterday, but they say the best time to have planted a tree was 100 years ago. The second best time is right now. And so that's what we've been doing, is creating this ecosystem. And we have a number of programs that we run with girls as young as 5 or 6 years old. And why so early in the STEM in the STEM value chain is that work that has been done by leanin.org shows that girls as young as 5 and 6 opt out of STEM, and they've been told and socialized that they're not good enough for maths and science. It's something that only boys do, and if you ask them to draw an engineer, they're typically going to draw man. And so it's really around how do we make sure that we have the positive role models out there speaking to girls around engineering careers. And then when we get into high school, it's really around how is it that we ensure that this younger generation who are very much mobilely connected and can think about the way the world works in very different ways are part of bringing them into the engineering industry. And then we work with university students to be able to make sure that they have the employability, entrepreneurship, and innovation skills to be able to go into industry and be the change that we want to see in a world that is very much technology-led. And then working with industry around how is it that we support women in leadership positions to be able to create that critical mass around diversity and inclusion. And then the last 3 pieces has been something that we've been really passionate about doing. And that's really around ownership. And if you think about the number of women in engineering is around 10%, the number of women owning businesses in the industry is even lower. Right? And so we've been really focused on fostering and building female-led innovation. And the reason being is a lot of the world has never been built or designed with women in mind. And so how is it that we make sure that we have this diversity to be able to create an inclusive world for us all, right? And so it's the whole idea that we actually remove the sexism and racism in engineering infrastructure itself by creating the diversity, equity, and inclusion. And so we've been working with entrepreneurs to be able to create businesses within the this industry that ultimately creates more jobs and new opportunities. But if you ask me, Amal, Nadia, what keeps you up late at night? And it's not just around how is it that we bring in talent into the sector, but it's really around how the technological change that has really been exacerbated by COVID-19. And it's really around how is it that we make sure that while our physical worlds may never have been designed with women in mind, our virtual worlds are safer and that we have women in mind when we create these worlds. And that is why we have been working on skills of the future at Womenj. And we've been working specifically around artificial intelligence and cybersecurity in two ways. In one way, we are working around how is it that we can reskill engineering current workforces to be able to leverage artificial intelligence and cybersecurity into our existing infrastructure and technologies. And the second one is really around how is that we keep people safe online. As such, WOMAB and Womenj have built a cybersecurity vulnerability index to be able to assess organizational vulnerability around cybersecurity. And we are training entrepreneurs, we're training engineers, and there's such a massive demand around how is it that we make sure that we build a safer virtual world. And so we've got an online academy that is supporting hundreds of participants to be able to upskill them in real time and give them the core skills to be able to transition themselves from just pure engineering to actually engineering and technology, which is a lot more encompassing. And I think a lot is where the need lies. And really what this conversation this afternoon is about, right? That we need to adapt the way in which we think about engineering more holistically to be able to incorporate new technologies. And so we have worked, while we are proudly South African, proudly African, we have worked around the world, including a commitment that we've made with UNESCO to empower 1 million girls through STEM education. We're at 100,000, and so we've got a little bit of way to go. But for us, it's really around how is it that we are able to not just activate ourselves, but activate 150 global ambassadors from around the world to be able to be part of this mission that is to be able to change the face of engineering and technology for the better. We work with a massive number of participants who are right now working at the coalface and being able to not just revolutionize the face of engineering, but support engineering innovation in a way that is able to make an industry more diverse and more inclusive. And in that way, embrace technology and embrace these skills. More than that, in a world where our economies have been decimated by COVID-19, engineering almost has a responsibility to be able to create more jobs. And it's always a pathway to more jobs and more success and higher incomes for all. And so that is why we're not just working around the attraction piece and the development piece, but the ownership piece as well. And not just in our traditional engineering industry, but also leveraging technology to be able to make it inclusive for all. Because ultimately, it's around achieving the Sustainable Development Goals. And we're not going to get there. And on the African continent, we have a proverb that says, if you want to go fast, you've got to go alone. If you want to go far, we've got to go together. And so for us to be able to achieve the SDGs, we have to work together collectively to get there further and faster. Thank you very much.
Thank you very much, Nadia, for this wonderful talk. I'm sure this talk will definitely excite our young women to pursue careers in engineering and in STEM. Thank you very much. Our next speaker is Mr. Wang Shuaigu. I'm sorry for the pronunciation, who is going to talk about online learning platforms. Mr. Wang Shuaigu is the president of Shuitang, which is an online learning platform founded by Tsinghua University, and the first global partner of the UNESCO Category 2 Center, the International Center of Engineering Education. Prior to joining Shuitang, he was responsible for the research of online education in Tsinghua. His online course was awarded the National MOOC of China with over 80,000 enrollments. In 2015, he founded the Rain Classroom, which is the most active teaching tools for higher education in China. Shuaigu holds a bachelor's degree and a master's degree in computer science and from Tsinghua University. Forgive me, Wang, for the wrong pronunciation, and the floor is yours.
Thank you. Dear Ms. Amela Ghazari, distinguished panelists, guests, and friends who are now online with us, good morning, good afternoon, and good evening. I'm Wang Shuaiguo, president of the XUTANG-X. I was very pleased to be invited to take part in the roundtable for World Engineering Day today, and happy World Engineering Day. And I would like to share the practice of XUTANG-X and UNESCO ICEE in serving global engineering education. XUTANG-X is the first MOOC platform in China, launched by Tsinghua University in 2013 with more than 8 years of development. XUTANG-X now has 4.5 thousand courses and 86 million learners, which has become the second largest MOOC platform in the world. XUTANG-X has offered more than 2,000 engineering courses from top large universities around the world, reflecting the latest development of industry and technology. So to today's topic, I would like to say online education can do a lot of help to engineering education. In 2019, XUTANG-X proudly became the first global partner of UNESCO International Center for Engineering Education. The two parties have jointly explored how to serve global engineering education. Since 2016, XUTANG-X has been responsible for the development and operation of online education platform of ICEE, serving global engineering education based on quality online education resources and delivering quality content to developing countries, including those in Southeast Asia and Africa. In order to improve the computer skills of university engineering students and train competent international engineering students, engineering, science, and technology talents, UNESCO ICEE, UNESCO ICAST, and XUTANG-X has jointly launched the micro degree in computer science. XUTANG-X and ICEE has launched an international outreach engineering training program to promote the application of engineering education knowledge service system. At the same time, XUTANG-X has also hosted the International Forum for Online Engineering Education for 3 years, aiming to explore the in-depth integration of online education, smart teaching, and engineering education, promote the sharing of the global quality resources in engineering education, and train more outstanding talents with global competence. What's more, XUTANG-X has also strived to use online education platforms and quality resources to address the teacher shortage in Western China. One example is Nanjing Internet School, a MOOC-based platform built for the career of teachers and the study of students, covering all schools in Nanjing County, Yunnan Province. The platform has empowered 1,800 teachers and director of education authorities, helped 25,000 students to obtain quality education resources, including 15,000 female teachers and students, and helped primary and middle school students in the county to study the courses of renowned schools and teachers and enjoy fair and quality education. On April 20, 2020, amid COVID-19 global pandemic, the international version of XUTANG-X has officially launched. XUTANG-X has been selected as a UNESCO distance learning solution, providing service for university students and social learners all around the world. During the COVID-19 outbreak, XUTANG-X and ICEE hold a seminar on online education and outlook for universities amid COVID with ICEE and Tsinghua University to share online teaching experience. XUTANG-X continuously explore novel forms of quality resources sharing and supports Tsinghua University in opening hybrid courses and global open courses around the world. In 2021, Tsinghua University's Global Hybrid Classroom offered nearly 50 courses for universities around the world, including big data, traffic analysis, and other engineering courses. More than 400 overseas learners attend the courses in real time with Tsinghua students. In the fall semester of 2021, Tsinghua University launched 8 global open courses in Xutang X with over 6.3 million learners all around the world. For years, Xutang X has been committed to establishing a two-way channel for the introduction and output of courses at China and abroad, as well as the global sharing of the quality resources. In 2020, Tsinghua University and 20 universities and institutions on reversed continents jointly launched the Global MOOC and Online Education Alliance for further cooperation. Xutang X is very proud to be a founding member and strives to help universities at China and abroad to carry out curriculum and teaching cooperation and exchanges, and especially on online education of engineering education. Recently, Xutang X has joined hands with 18 Chinese universities to offer 60 top-notch MOOCs to Indonesian university students, covering diverse disciplines, including computer, artificial intelligence, engineering, biology, and medicine. And that's all for today, my presentation. And I'm looking forward to more in-depth discussion later. Thank you very much.
Thank you very much, Wang, for letting us know how we can take engineering education around the world with MOOCs. Thank you very much. Last but not least, we have Mr. Wahid Azizi, who is going to talk about engineering skills. Mr. Wahid Azizi is the engineering skills where they are most needed program manager. This is known as ESMM. He's a program manager with the Royal Academy of Engineering since April 2019. Prior to joining the Royal Society of Royal Academy of Engineering, he has worked as an advisor, manager, managing humanitarian, rehabilitation and development project and programs in Afghanistan and Pakistan. He managed life-saving projects in refugee camps in Peshawar, in addition to managing a national rural roads program in Afghanistan. He holds MBA from Cardiff Metropolitan University in the UK and Master in Chemical Engineering from Kabul Polytechnic University in Afghanistan. Wahid was awarded a Fulbright Scholarship and attended a one-year Urban and Regional Development Studies Fellowship program at MIT in the USA. In addition, he was awarded 2 years scholarship by UNITAR in Japan and achieved a one-year fellowship program in coaching, management, and leadership. And the second year, Wahid has the honor of coach new UNITAR fellows in their project. Thank you, Wahid, for joining us, and the floor is yours.
Happy World Engineering Day. Hello, everyone. Thank you for having me today, and thank you for the introduction. My name is Wahid Azizi, and I'm the program manager for the engineering skills, where they're most needed. Program Engineering X is a collaboration between collaboration founded by the Royal Academy of Engineering and the Lloyd Register Foundation that brings global experts together to engineer change. I'm a chemical engineer by training from Kabul Polytechnic University, Afghanistan, with an MBA from Cardiff Metropolitan University in 1 year MIT Fulbright Fellowship Scholarship in Urban and Regional Studies. Prior to joining the Academy, I managed humanitarian rehabilitation and development projects in Afghanistan and Pakistan. These focused on life-saving operations at refugee camps, rehabilitation rehabilitation of war damage, engineering infrastructures, and urban and rural transportation development projects and programs. I know firsthand of the critical importance of engineering skills in managing complex projects and challenging environments, and the need to equip engineers with the skills required for our ever-changing world. Today, I'm going to speaking to you about our work in engineering skills, where they're most needed program, and what we have learned about engineering skills needs now and in the future. What is the challenge? We began the engineering skills program in 2019, which aims to support the delivery of skills in education programs that will lead to the development of much needed domestic engineering skills capacity, enhanced safety standards, and infrastructure that remains safe and fit for purpose. We started our journey wanting to understand which skills were most needed and where. In Engineering X, we always strive to take an evidence-based approach. In 2019, we launched the Global Engineering Capability Review, which shows the breadth and diversity of engineering strengths and weaknesses around the world. And it includes the Engineering Index, which measure the extent to which 99 countries can conduct engineering activities in a safe and innovative way. In addition, we examined specific engineering capability issues through case studies in 6 different countries: India, China, Colombia, Ethiopia, Thailand, and Jordan. What we learned, the report revealed some shocking headlines, statements. We learned that every day around the world, more than 1,000 people die due to an accident at work. Moreover, data from an International Labour Organization showed that fatal occupational accidents are increasing in many developing countries. The report reveals some of the challenges that highlighted in the report.
Some very insightful and interesting discussion that's happening at the UNESCO today. That was, of course, the panel discussion where we had panelists talking about various challenges that the world is facing today and how the UN can actually work towards building a more sustainable future. And that can't happen without the input of someone very important, people called engineers. That's right. Welcome back to the studio. This is World Engineering Day 2022 for a sustainable future. And with us, we have someone very special now. It's an engineer who goes by the name Mustafa Shehu. And he, of course, is the Executive Vice President of the World Federation of Engineering Organizations. He's worked in the sector of power generation, designing systems, also in green technologies, and designing many other systems. And he's here with us. And we'd like to ask him some very important questions on World Engineering Day. So welcome, Mustafa.
Thank you very much. You are all welcome, and happy Engineering Day to all the engineers and non-engineers across the globe. Good morning, good afternoon, and good evening.
Of course. Thank you so much. It's great to have you on board. And I'd like to ask you a very pointed question. What does World Engineering Day mean to you?
Well, actually, World Engineering Day means a lot to me because it reminds me of the day some international engineering institutions met and formed, a global engineering institution called the World Federation of Engineering Organizations, with a view to addressing global problems and with a view to sharing experiences across the globe. Because these engineering institutions that met came from different parts of the world, some from the Americas, some from Europe, some from the Commonwealth Engineering Council, some from the Federation of Arab Engineers. And in their wisdom, they found that there is a strong need for the engineering community globally to come under one umbrella so that we share ideas, we share thoughts, and also we face global challenges facing our communities. And up to today, the aim of that association is ever increasing, in terms of purpose, because they need to come together as a global community is ever becoming more important. And the challenges across the globe also needs global effort. And so the umbrella of WFO has really served and is serving and will continue to serve the global community towards addressing global challenges. And another thing I feel passionate about is to congratulate the WFO for having this day being recognized by the UNESCO. And I also feel very happy that I'm really part of that. I'm really part of that effort of the WFO leadership some 3 years ago. That I mean, this World Engineering Day is being recognized and approved by the UNESCO. So it means a lot to me. It means a lot to the global engineering community, and of course, it should mean a lot to the entire citizens of the world.
Of course, being recognized or having the day recognized as World Engineering Day would have had its own set of challenges. I'm sure it wasn't easy, but of course, I'm sure there are a lot of passionate and committed people working behind that. So that brings me to my next question. Why is it so important to celebrate World Engineering Day?
Well, it is so important to celebrate this day because we have global challenges. The global community under the United Nations leadership have signed the Sustainable Development Agenda. And under this Sustainable Development Agenda, you have about 17 Sustainable Development Goals. Many of these goals, or most of these goals, have their solutions deep-rooted in engineering. Or even those that are not deep-rooted in engineering, you discover that engineering plays a key role in attaining those sustainable development goals. So for us as engineers, it is very important to make this day very audible, very clear to the leadership of the international community, to the leadership of our continental political leaderships, and also to the leadership of our individual countries, that these sustainable development goals cannot be achieved without engineering. And the engineers are very much available and willing to participate and partake in addressing these challenges. And it is also a wake-up call for all of us as engineers to know that it is very important not only to limit ourselves to serving in the engineering sphere, but we should also make effort to avail ourselves in the political domain and also in the leadership at the executive level and at the legislative levels of our country, so that these solutions that are deep-rooted in engineering will be solved much faster and more effectively if a lot of us are key players in the political sphere.
The pragmatic and solution-seeking attitude that engineers have actually contribute towards a better world and building. And like you said, I would love to see its ambit grow within other spheres also, such as the political sphere or normal day-to-day life as well. But having said that, it's very important how we build a sustainable future. How does World Engineering Day plan to address that?
Well, the World Engineering Day plans to address that through continuous advocacy to both the engineers, the engineering institutions, and the general public, and also to let the engineers know that it is normal. It is normal, the best to say that you are an engineer or you are an electrical engineer and you have nothing to do with finances. You have nothing to do with the politics. You have nothing to do with the economy of our country. We need to be not only engineers, but we also have to have broad-based, knowledge of so many things that surrounds us, so many things that affects our life and affect the life of our community. So as engineers, we use this day to bring this advocacy, to the highest level, to both ourselves, our political leaders, and our legislative leaders also.
So what work will WFEO be doing specifically in your region for sustainable development?
Well, first of all, the WFO as umbrella body of all the engineering institutions in the world has a lot of programs, and these programs are being implemented in the respective countries of those national members. So our expectation is that, number one, the communication and collaboration between the WFO and the national member institutions has to be continuously improved so that the policies we are and programs we are promoting at the global level goes down to the continental level and as well as to the national level. And we also expect the national member institutions to bring up issues of concern to them that will require global solutions or some assistance by the global engineering community so that together we can solve the the local problems and as well as the continental problems. We also have to make sure that even the WFO expands in its area of jurisdictions. We have so many national members that are in the membership of the federation, but there are still many more countries that are yet to register with the World Federation of Engineering Organizations. So it has to be our continuous effort to make sure that more and more countries register with WFO so that the effort we're making in WFO that affects many countries gets to get to every country in the globe. So that our effectiveness will be more global and will be benefited by all countries and all regions of the world.
Best of luck with that. And I do hope that all countries in the globe sign up to the WFEO. And tell me something, with the moving times, there will be changes, lots of them. What changes and challenges that you see for engineers and engineering in the coming future?
Well, the challenges are really many because technology is taking a lot of jobs that hitherto many people are doing, and these technology improvements or developments are real. So as engineers, we have to foresee this future and also adjust ourselves to make sure that we benefit from those advances in technology. While some jobs are being phased out, really many jobs also are being created. So as engineers, we have to look forward not to make sure that we are being aged out or we become endangered species in the sphere we are all operating. So these are the key challenges that we engineers have to be very mindful of, and we have to breast ourselves to make sure that we come to terms with those challenges, and as well as position ourselves to make best advantages of those changes that are coming due to advances in technology.
Thank you so much for your insightful comments and thoughts and sharing them with us also, Mustafa. And of course, before we go, I'd like to ask you a message from yourself to the engineers of the world and to the world itself who's logged in to watch us.
Well, my message to the engineers of the world is that, first of all, everybody who has found himself to be an engineer, he should be proud to be an engineer. And it's not only to be proud to be an engineer, you should identify 1, 2, or 3 problems that affects your community and make sure that you solve those problems so that people will see the value of an engineer around them. It's not enough to say that you're an engineer and you pride yourself as an engineer without solving problems around your people. So let us identify problems around our people and solve those problems. And also let us mentor a lot of other young people who are just growing or who are just going into the engineering profession. It is our duty and obligation on us to make sure that we churn out more engineers in the future, and the young engineers that have graduated, in recent times, we make sure that number one, we avail them of the opportunity to practice engineering, and number two, also we make sure that they partake in solving the problems surrounding their environment, surrounding their country, and surrounding their regions. So this is the message I want to take to all the members of the engineering community globally.
Thank you so much for those insightful and sharp comments. And I hope all of us who have been watching and following those words really get something out of it. Thank you so much, Mustafa, Executive Vice President of WFEO. And now it's time once again to come back to the studios where we are going live 24 hours from coast to coast, from one end of the globe to the other, ending at Costa Rica. And we've just finished Ghana. That's right. So ladies and gentlemen, we have a lot more coming up, but be excited, stay excited, because right from the computer that you're watching this on, from the phone, and also the shoes you're wearing or the television that you're watching, it all is made possible by engineers. Ladies and gentlemen, 4th of March, World Engineering Day. Don't forget, log on to worldengineeringday.net to watch us live as well. I'm signing off. My name is Karthik Mohandas. And once again, let's all celebrate World Engineering Day for a sustainable future.